Hello dear student, how are you all? I hope you are fit and fine and ready to rock. Myself Karthik Shah and I welcome you all in this amazing platform of learning called Physics Wala. And yes, myself Karthik Shah, I welcome you to this amazing batch for upcoming NEET 2025. Welcome you all in this UMEED batch. I welcome you all. Yes, today in this UMEED NEET English batch. Yes, this batch is going to be completely taken in only English language. And yes, in this amazing batch, today we are going to take a most amazing chapter of a physical chemistry. And yes, it is a mole concept. Most probably from last 5 to 6 years approximately every year NEET paper setter always choose 2 to 3 questions from this topic. Mole concept is the most fundamental chapter of a physical chemistry, and every year there will be 2 to 3 question comes out straight out of this chapter. And yes, one more important thing about this chapter is it can be combined with any inorganic or organic chapter also. Yes, many times we have seen a question which has a combination of a organic chemistry with mole concept, inorganic chemistry chapter with mole concept. So basically mole concept is a basic fundamental and base chapter of chemistry. If you learn this chapter perfectly in this UMEED batch, one short lecture, you get secured your 2 to 3 question in your NEET examination. And beta, 2 to 3 question, it means 8 to 12 marks, which is more crucial marks for getting admission in MBBS college. Yes, your dream and my dream are same. Your dream is to getting admission in a government medical college, and my dream is achieving your dream completely is my dream. Yes, I am going to help you to achieve your dreams. And yes, our target is common and it's NEET 2025. How to crack this NEET 2025? First of all, before we start mole concept, let me understand about the NEET examination. Yes, for NEET 2025, make sure paper pattern will be the most probably same as the last one's 2024 paper pattern, but possibilities of some change will be there. Obviously, till the January end, you get the clear information about the change of system if NTA will change, right? Yes, so NEET 2025 paper will have chemistry's question. Chemistry subject contains first 35 questions in your section A, and from section B there will be a 15 question. These 35 question is compulsory, so you have to attempt these 35 question compulsory. From these 15 questions, you have to attempt only 10 questions, right? After COVID, the paper pattern would be changed and these change will be implemented by NTA. So now overall, you have to attend 45 questions. There is one probability that maybe this 5 option question will be removed by NTA soon, because in JEE, this change would be implemented already, right? So it is possible, the possibilities will be there that next NEET paper will contain only 45 question of chemistry. No option will be given. Doesn't matter. For our target of NEET 2025, we must do cover all the chapters of chemistry perfectly. Yes, and I am your chemistry mentor. I am going to teach you physical chemistry completely and some part of inorganic chemistry, right? In this UMEED batch, in this UMEED NEET 2025 batch, we are going to learn all physical chemistry and half inorganic chemistry perfectly, right? To cover up your 180 mark into 4 marks. So our chemistry papers would be of 180 marks. So our dream is to achieve these 180 marks, right? So before we going to start a mole concept, remember the mole concept chapter, there will be always 2 to 3 MCQs. Directly comes from this chapter, mole concept, and one combination of mole concept with any physical, inorganic or organic, right? So it must be contain 2 questions or 3 questions directly from this chapter. So if they ask 2 questions, the weightage of this chapter would be 8 marks, or if they ask 3 questions, then the weightage of this chapter will be 12 marks. So it is your chapter weightage for upcoming NEET 2025. It is your chapter weightage for NEET 2025. Done. Now, what are the important topics of this mole concept will be asked in your upcoming examination? And in this one shot, which are the most important key concept which we are going to focus more? The concepts are these 4 topics. It is the most crucial topics. First is atomic mass and molar mass. It is a basic mole concept. In this atomic mass and molar mass, basically we are going to learn about the mole. What is exact meaning of mole, right? Next topic is stoichiometry. It is the most important topic in previous years. Every year, each and every single year, there will be at least one question asked from this topic. So it is the most important topic, right? Then limiting a reagent, it is also the part of stoichiometry concept. And yes, there will be a few times we seen in previous years, there will be question asked from this topic also. And in last topic, which is your concentration term, which is also have the connection with the chapter called solutions, right? So here we are going to focus on these 4 topics perfectly. Okay, let me begin from our first session from mole. What is basically mole concept? What is basically mole? See, the numbers of atoms present in 12 gram of carbon 12 isotopes. First of all, you don't know about the isotope in detail, right? But in today's session, we are going to teach you about isotope also. But what is a 1 mole basically? So 1 mole is the number of atom present in a 12 grams of a carbon 12 isotope. It is called mole. See, 1 mole means Avogadro numbers. It is denoted by 6.022 into 10 to the power 23. It is its value and it is denoted by the Na, which indicates your Avogadro number. Basically, beta, the quantity of matter is measured in the mole, in mole. If we talk about the mass, quantity of mass, which we measure in the kilogram or gram, quantity of any liquid, which we are measuring in volume, liter, ml, etc. Same way, if we going to measure the quantity of matter, yes, that will be going to be measured in a mole. So basically 1 mole of any unit, any unit means, sir, maybe it is going to be your atom or molecules or ions, anything. 1 moles of atoms, 1 moles of molecule or 1 moles of ion. It means that It is 6.022 into 10 to the power 23 units. Now, if you are going to take unit as a atom, then it will be atoms. If you are going to take unit as a molecule, then it will be a molecule. And if you are going to take unit as a ions, it will be number of ions. So, it is a basically fundamental concept. 1 mole equals to the mass or the atoms present in a 12 graph of carbon 12 isotope is called 1 mole. Done beta? Now, mole have a several relations. Mole have a several relations with different quantities. Which quantity? Kind of mole have a relation with a mass, mole have a relation with a volume, etc. Let's discuss another formulas for the mole. First formula of a mole is in terms of a mass. Mole in terms of mass. And one more thing beta, mole is denoted by eta. Mole is denoted by eta. Later on, eta will be transferred into small n. So, if mole can be denoted by both the things, eta as well as n. Now, what is mole in terms of a mass? Simple formula of a mole in terms of a mass is moles equals to given mass divided by molar mass. Given mass divided by molar mass. So, from given mass we can also measure mole, and this formula is now denoted by the given mass is small m and we denote molar mass with the capital M dash, so that we can simply find mole with respect to mass. Now, let me do some numerical based on this concept. First numerical is we are going to take is a very simple numerical, right? Let me start. Find moles of 36 gram of water. What is the moles of 36 gram of water? For this, you have to know the molar mass of water. So, molar mass of water is 18 gram per mole, right beta? And mass is given, which is 36 gram. Then, what is the formula of mole? Mole becomes given mass upon molar mass. So, beta, given mass is 36 gram, molar mass is 18. So, your moles becomes 2 moles. Clear? So, by this method, you can simply find moles with help of mass, given mass and molar mass. But this can be asked in a reverse format also. So, from this mole formula, we can also find mass. If mole is given, then mass becomes mole into molar mass. Your mass becomes moles into molar mass. And same type of different question can be asked like this. Alternate question. Find mass of 2 moles of CO2. 2 moles of CO2. Basically, for this sum, you have to know about the molar mass of CO2. What is molar mass of CO2 beta? Molar mass of CO2 becomes atomic mass of carbon plus atomic mass of oxygen into 2 plus twice into atomic mass of oxygen. For this concept beta, first of all you have to remember 1 to 20 element and their atomic mass. Carbon's atomic mass is beta 6, right? Now twice into atomic mass of oxygen is 16. Carbon's atomic mass is 12. Sorry, atomic number is 6, atomic mass is 12. So 12 plus 16 2s are. So 12 plus 32, it becomes 44 gram per mole. Right beta? So it is molar mass of carbon dioxide. Now beta, we have to find mass of 2 moles. Then what will be the formula? Moles equals to we have to find mass, right? Moles equals to mass upon molar mass. Let me make mass as a lead. So mass becomes mole into molar mass. Moles into molar mass. So now beta, your mass becomes 2 moles is given into 44 gram per mole is its molar mass. So twice into 44 it becomes 88 grams. Done beta? So from these two formulas you can find moles from mass and you can find mass from moles with help of a molar mass. It is a simple first formula of mole in terms of mass. Let me move forward another formula. Another formula is also important. With the help of a mass, we can find mole. Now, we have to see the new formula of mole in terms of, now, moles in terms of gaseous volume. In terms of gaseous volume. This formula is only for a gaseous element. Make sure, make star here to remember this relation is only for, this relation is only for gas state or gaseous state. Then strictly beta, the limitation of this formula is it is only applicable for a gaseous state. See, let me understand what is the formula of mole in terms of gaseous state. This formula consideration at a STP. What is STP beta? It means at a standard temperature and pressure. Make sure again this formula have two different conditions. First is it is only applicable at a gaseous level. And second is it is taken as a STP and NTP also. What is NTP? It is natural temperature and pressure. So this formula is applicable at STP or NTP. Let me write a difference between STP and NTP here. STP is the standard temperature pressure. NTP is a natural temperature and pressure. At STP beta, we are going to take temperature. Yes, temperature in Celsius and Kelvin both. Temperature will be 0 degrees Celsius or 273 Kelvin. At NTP, temperature will be considered as a, yes, 25 degrees Celsius or 298 degree or 298 Kelvin. Right beta? Next thing, in the both the case, pressure will be taken as a same. Pressure will be considered as a same. 1 atmosphere or nearby 0.987 considered as a 1 bar. So pressure will remains the same. 0.987 bar we considered as a 1 bar. Done beta? Now what is the formula beta? Basically what is the formula of a moles for gaseous state? Formula of a moles at a gaseous state at STP or NTP will be moles becomes volume divided by 22.4 liter. Basically it is given volume of gas divided by 22.4. Yes, this volume must be considered in a liter. But this formula is strictly applied at a STP or NTP condition. Rather than if we change temperature between these two, this formula cannot be applied. STP or NTP. Done beta? Yes. Now from this formula you can also find moles, and from volume also can be found by this formula. Volume becomes mole into 22.4. The answer will be in a liter. It is another important formula. Moles in terms of a gaseous volume. Let me do one simple numerical. Find moles of H2 gas which had volume of 11.2 liter at STP. See, in this question we have to find moles of hydrogen and the volume is given. So now formula of a moles in terms of the volume is volume divided by 22.4 liter, and this formula is strictly applied at a STP or NTP. So here STP is given condition. So moles becomes 11.2 divided by 22.4. So it becomes 1 by 2. So your moles become 0.5 moles. Now beta, let me move towards the second type of question which can be asked from this topic is find volume of 3 moles of helium gas at STP. If the condition is not given, by default you can take it as STP. Now what will be the formula of volume beta? Volumes becomes mole into 22.4 liter. So here mole is given as a 3, so it becomes 3 into 22.4. So it becomes 4 3s are 12 plus 1, 3 2s are 6 plus 1 7, 3 2s are 6, 67.2 liters. Done beta. By this simple formula you can find volume with the mole and you can also find moles with the volume. Now let me move towards the another formula of a mole, which is mole in terms of particles, molecules rather than particle, we can call molecules, right? What is the formula of moles in terms of molecules? We have another simple formula. Moles becomes number of molecules divided by Avogadro number. And yes, we already studied about Avogadro number. What is Avogadro number? It is 6.022 into 10 to the power 23. It is 6.022 into 10 to the power 23. If I am telling that number of molecules can be represented by capital N, Avogadro number can be represented by capital Na, your formula of moles becomes N by Na. And vice versa, by the help of a mole, you can also find number of molecules, which is moles into Avogadro number. It is the third relation of a mole. In first relation, we have see formula of mole in terms of mass. In second relation, we see relation of moles in terms of volume. And in third case, here we are going to see the relation of moles with the number of molecules. Let me do one numerical. Question. Find number of molecules present in present in 3 moles of methane. Right? We have a simple formula. Number of molecules equals to number of molecules becomes mole into Avogadro number. What is mole? Which is given in a question. 4 moles into Na. sometime in option the answer will be in the terms of a Avogadro number, then you have to choose the answer from this way. But if answer not given in a terms of Avogadro number, then you have to put the value of Avogadro number here. It is 6.022 into 10 to the power 23. So beta 4 to the 8, 8, 0, 24. 24.088 into 10 to the power 23. Let me convert this number into scientific notation. Then it becomes 2.4088 into 10 to the power 24. In the scientific notation method, please make sure here in this one short lecture, we are not going to stick to study of this part, scientific notation method or a specific number. These all things you are going to study in a physics also. So here in chemistry, we are going to do directly these things in a numerical, right? So scientific notation says that before the decimal point, there will be only a single digit, which never be a zero. So it will become 2.4088. If we take this decimal point to the one left side, then the power will be increased. So it becomes 10 to the power 24. So now we finally have our numbers of molecules, and it is 2.044 into 10 to the power 24. Now from this molecule part, you can also find number of atoms also. See, this one molecule of CH4 is made with the 1 atom of carbon and 4 atom of hydrogen. The smallest part of any element is called as atom, right? Dalton gave this definition. So I can write that 1 mole of CH4 will contain 1 atom of carbon, and 4 atoms of hydrogen. So for this some further, if they ask about number of total carbon atom, then you can write the equation like this: number of total carbon atom is equals to 1 carbon in 1 CH4. So 1 into number of molecules. So it becomes 1 into 2.4088 into 10 to the power 24 atoms. So finally it becomes number of total carbon atom, becomes 2.4088 into 10 to the power 24 atoms. Now if they ask about hydrogen atoms, this sum is continued, please follow. Number of hydrogen atoms, total number of hydrogen atoms, it becomes, there will be 4 atom per molecule. So it becomes 4 into number of molecules. And yes, 4 into 2.4088 into 10 to the power 24. So your answer becomes, yes, you have to do these calculations. Approximately these can be taken as, for a NEET examination, 4 into 2.41 into 10 to the power 24. So it becomes 4 ones are 4, 4 fours are 16, 4 twos are 8 plus 1 9. 9.64 into 10 to the power 24 molecules. Done, beta. So by this method we can find number of atom as well as molecules also. Let me do another question. Beta. Find number of glucose molecules in 2 moles of glucose. 2 moles of glucose. Also find number of carbon atoms, oxygen atoms and hydrogen atoms and total atoms in it. In this question, I am telling you that the answer will be taken as in Na terms, in a Avogadro number terms. Okay, let me begin. First thing, find number of glucose molecules in 2 moles of glucose. So here the data is given is only moles of glucose is 2. Formula of glucose, we all know that it will becomes C6H12O6. Right, beta? Now, what is exactly number of molecules? Formula for N, which is your number of molecules. So, formula of number of molecules is moles into Avogadro number. So, now, number of glucose molecules is becomes twice into Na. So your answer in the terms of a Avogadro number is 2Na. Sometimes they give an option like I told you already in the previous question in the terms of a Avogadro number. Then you don't need to further simplify answer. Please stay as it is in a Avogadro number. So now it is number of molecule. Now sir, what is number of atoms of all the things? We have to find the number of atoms of carbon, number of oxygen atoms and number of hydrogen atom as well as total numbers of atom. So let me begin with the carbon atom. So number of total carbon atom. See, in 1 molecules of glucose, there will be 6 atom present. So, in this much molecule, how many number of atom present? So, it becomes 6 into number of molecules. And it becomes 6 into 2Na. So, it becomes 12Na. Done, beta? Number of carbon atoms present is 12Na. Now beta, number of total oxygen atom, it becomes total, there will be 6 oxygen again. So 6 into number of molecules. So it becomes 6 into 2Na. So it becomes 12Na. Now beta, number of total hydrogen atoms, it becomes, there will be 12 hydrogen in a 1 molecule. So it becomes 12 into number of molecules. So it becomes 12 into 2Na. So it will be 24Na. So individual atoms of carbon is this, individual atoms of oxygen is this, and individual atom of hydrogen is this. Now what about the total atom? If you add these 3, you can get total atoms. Or other method is, see, number of total atoms present. Total atom which present in the 2 moles of glucose is, see, 6 plus 12 plus 6. 6 plus 12, 18, 18 plus 6, 24. So 24 into number of molecules. And yes, we have number of molecules as 2Na. So it becomes 24 into twice Na. 24 into twice Na. So it becomes 48Na. 48Na. So by this method, by this formula, you can simply find number of molecules from mole, also find number of atoms from mole. Clear beta? Let me do one more example of this concept. Let me do one more question of this concept. Find number of moles present in 3 trillion water molecules. See, we have 3 trillion water molecules. First of all, let me clear some important concept about million, billion and trillion. See, 1 million is 10 to the power 6. 1 billion is 10 to the power 12. And what is 1 trillion? 1 trillion means 10 to the power, billion becomes 10 to the power 9 and trillion becomes 10 to the power 12. Million, billion and trillion. Remember these three terms. It is important, right? So now we have these terms. So we have to find 3 trillion water molecules mole basically. So number of water molecules is equals to 3 trillion. So your capital N becomes 3 trillion. Trillion means 10 to the power 12. So basically it becomes 3 into 10 to the power 12. Right? Now what is mole? What is mole? So your moles becomes number of molecules divided by Avogadro number. What is number of molecule? 3 into 10 to the power 12 divided by 6.022 in round off. You can consider this 6.022 as a 6. 6.022 into 10 to the power 23. Right? So now it's 3 to the 6 approximately. So 1 by 2 becomes your 0.5 into 10 to the power plus 12 minus 23. So it becomes 0.5 into 10 to the power minus 11. Right? Minus 11. So if you do this, convert this term into scientific notation, it will become 10 to the power minus 12. Right? So basically you can find moles from molecules by using this formula. Done. So yes, we already learned 3 different formula for the moles. Which 3 different formula beta? First is mole in the terms of mass, second is mole in terms of a volume, and the third one is moles in terms of numbers of molecules. Let me make a clear graph of mole. See, mole is a center part of this chapter. It is denoted by eta. If we have mass, given mass, we can also find mole. We can also find moles by using mass. If we have volume and if we have number of molecules or atoms. See here volume, but it is strictly applicable for a gas. Remember, please make star here. So you have to remember this. It is only for a gaseous state. Now at STP or NTP. Now the last thing, number of molecules. If they give you number of atoms, then you have to find number of molecule with the help of number of atom. Then you can find number of mole with the help of number of molecules. So remember these 3 things. From these 3 different things, you can easily find moles. But the important key factor is their formulas. Let me write their formula over here. Mole is given mass upon molar mass. moles becomes volume divided by 22.4. Please make sure at STP or NTP. This formula is useful, like mole equals to number of particle divided by Avogadro number. Done beta. And again same thing, with the help of a mole you can easily find three different things: mass, volume and molecules or atoms. Again I repeat this, you can find mass with the help of mole, you can find volume with the help of mole, and you can find number of molecules or numbers of atoms, or from these you can find number of atoms also. So sir, we totally understood from mole we can find these three different parameter. Let me write again their formula derived from this formula. Your mass becomes moles into molar mass, your volume becomes mole into 22.4 liters. Please make sure again to make star here, it is only for gaseous state and the condition is at STP or NTP. At STP or NTP. It is a key factor. And the last number of molecules. So for this formula of N becomes mole into Avogadro number. So it is basically a principal chart. Now let me see the magic of mole. From any mass we can also find volume. From any volume we can also find number of molecule or mass. From any number of molecule we can measure its volume or mass. So basically mole is bridge between these three quantities. We can find any one quantity with any other quantity with the help of mole. Clear beta? Yes, theoretical se clear, but if we do one or two interesting example, then sir it becomes crystal clear from clear. Yes, am I right or wrong? Let me solve some examples. Interesting examples. Let me begin with the question number 1. Find volume of 32 grams of methane gas at STP. See, here in this numerical we have to find volume from mass. We have mass and we have to find volume. So first of all we have to convert this mass into mole and then we have to find volume with the help of mole. Done. Let me do the same thing. First, mass is given as a 32 gram. Now what is its mole? Its molar mass, first of all, for CH4 it becomes 12 of carbon plus 4 into 1 of atomic mass of hydrogen is 1. So 4 into 1, so it becomes 12 plus 4, 16. Now beta, what is mole? Mole is mass upon molar mass. It becomes 32 divided by 16, so 2 moles. Here we have 2 moles, right? Now we have to find volume. So for volume we have formula volume equals to moles into molar mass. It is basically little bit lengthy process. I am going to teach this same question from your smart method also. But first of all, listen, it is a basic method. So now what is the mole? Mole is 2 sir, and for volume it will be a 22.4 liter, right beta? So now sir, 2 into 22.4. Yes beta. So it becomes 44.8 liter. So by this method our sum can be solved. But sir, do we have any smart shortcut method? Yes, we have a smart shortcut method for this question. Wait a moment. Wait a moment. Yes. Again, same question on a repeating mode. How can we solve these questions smartly? The smart method which I call is KKC. Sir, what is this KKC? We don't hear any terms like KKC in chemistry. Beta, it is Karthik-sir's key concept. Karthik-sir's key concept. And remember, the key concept is very useful to getting 4 marks in any MCQ in NEET examination. So remember, this KKC is an important thing, and it is Karthik-sir's key concept, KKC. Right, beta? So we can find directly volume from mass. How, sir? How, sir? If you consider molar mass as a mass, then you can write a shortcut trick. Molar mass as mass, then your mole become 1 mole, and in that scenario your volume becomes 22.4 liter at STP. Remember, it is a key point to remember. So from this key point, I can write that molar mass of CH4 is 16 gram per mole. Right, beta? So I can directly write that 16 grams CH4 contains 22.4 liter volume. 22.4 liter of volume. Then we have in question is 32 gram of CH4. So 36 gram of CH4 contains dash question mark liter of volume. So beta, it simply becomes cross product 32 multiplied by 22.4 divided by 16. 16 twos are 32 and it becomes 44.8 liter. So it is key method by Karthik sir. You can do both them, but it is the easiest method. First time, do understand this perfectly. 1 mole becomes when we are consider or talking about 1 mole, then your mass becomes your molar mass, and at 1 mole your volume become of a gaseous state will be 22.4 liters. So you can directly say that when mass considered as a molar mass, your volume becomes 22.4 liter. Then you have to simply apply this cross product. Done, beta. Let me do a vice versa question. Little bit vice versa question. Let me do it. Let me do it. Question. Find mass of 11.2 liter of CO2 gas at STP. See, in this numerical, we have to find mass with help of volume. See, we have volume, we have to find mass. So, sir, can we apply this formula reversely? What type of reversely? Please listen carefully, beta. 22 liter of any gas contain mass at STP will be its molar mass. So I am writing down the statement. See the statement, 22.4 liter of CO2 at STP have molar mass gram. And what is the molar mass of CO2? We already find in a previous sum. 12 plus 16 twos are 32. It becomes 44 gram per mole. Done, beta. Am I correct? Yes. Okay, sir. So, sir, your statement becomes 22.4 liter CO2 contains 44 gram of CO2. Yes, beta. At STP. Yes, obviously. Now, We have 11.2 liter. 11.2 liter of CO2. Then how many grams of CO2 we have? So simply it becomes cross product. Mass of CO2 becomes 11.2 into 44 divided by 22.4. 11.2 divided by 22, so it becomes 2. 2 by 44, it becomes 22 gram. So finally we have the answer. Mass of CO2 becomes 22 gram. So by this simply shortcut technique, we can find any of the quantity between them. Any of. Now you have get clear idea about mass to volume and volume to mass. Let me turn down another point. Let me move towards the another point. Find mass of 10 Na ethane molecules. Ethane molecules. See, in this question we have numbers of molecules, and from these numbers of molecules we have to find mass of it. So sir, do we have the correct formula? Yes beta, we have. If the molecule is Na, then your mass becomes molar mass. For 1 mole there will be a Na molecule. So mass becomes molar mass. So you can write that what is the molar mass or formula of ethane? Remember, C2H6 is your ethane. And molar for mass of ethane will be 12 2s are 24, 24 plus 6, 30 grams. 30 gram per mole. Right? So in this case, you can write a straightforward statement like if Na molecule will be present, if Na molecules of ethane contains 30 gram of ethane, 30 gram of ethane, then 10 Na molecules of ethane contains how many grams of ethane? How many grams of ethane? Straightforward, it is a cross product question, sir. It is a cross product question. Now mass becomes 30 into 10 Na divided by Na. Na gets cut. We have 300 grams. We have 300 grams of ethane present. Done beta. So it is your tricky questions, which now by this shortcut method you can do like this. So please make sure on your chart page do write one thing. Do write one thing. And please give it name as a KKC. Karthik sir's key concept. Karthik sir's key concept. 1 mole equals to Na molecules equals to molar mass gram equals to 22.4 liter volume. Yes, at STP or NTP. This is your key concept. It is a master key to solve MCQs like this. Done beta. I hope you get understood it clearly. It's a simple smallest system. By these you can solve any mole concept sum easily. Now let me do another one example of this. Then after it we are moving from another topic. Let me do one simple example. Find number of molecules. Number of molecules. See, they can ask about number of atoms also. But for atoms, first of all, you have to find number of molecules. Find numbers of atoms present in 180 gram of urea. Find numbers of total atoms present in 180 gram of urea. See, what is the formula of, sir, urea? Urea is an important component which is going to be used in a previous years as a fertilizer. So, formula of urea is NH2CO NH2. And yes, molar mass of urea becomes 2 times nitrogen. So, it becomes 14 2s are 28. There will be 4 hydrogen. So, 4, 1 carbon 12, 1 oxygen 60. So, it becomes 60 gram per mole. Right, beta? Molar mass of urea is 60 gram per mole. Now, find the numbers of atoms present in 180 gram of urea. So, first mention thing, for atoms, we have to find molecule first. Molecule first. Right? So, for the help of the mass, we can straight away find number of molecule. Its molar mass is 60. So, molar mass is 60. So, 60 gram of urea, which is equals to 1 mole, contains Na molecules. Na molecules. Now, from 180 gram of urea, 180 gram of urea contains how many molecules? Simply, it's a cross product, sir. Yes, beta. It's a cross product. 180 into Na divided by 60. 180 into Na divided by 60. So, finally, we have numbers of molecules of urea. Not atoms. Not atoms. So, urea molecules, we have 3 Na. Now, it's time to find numbers of atoms. So, now, number of atoms in 1 molecule of urea. 1 molecule of urea is, see, there will be 1 nitrogen, 2 nitrogen, 2 hydrogen, 2 hydrogen, 4 hydrogen, 2 nitrogen, 6, 1 carbon, 1 oxygen, 7, 8. There will be 8 atoms present in 1 molecule of urea. Then, in 3 Na molecule, how many numbers of atom present? Yes, you can do by this simply cross product thing also. Otherwise, you have formulas. Numbers of atom equals to number of molecules into atoms present in a 1 molecule. Right? So, it becomes 3Na into 8. 3Na into 8. Your answer becomes 8 3s are 24 Na atoms. Done, beta? So, by these method, you can simply find numbers of atoms from any quantity, whether it will be given in a gram, moles or volume at STP. Now, let me begin to the next important part of a mole concept. For mole concept, sometime they can ask about number of proton, neutron and electron. But before we are going to study about number of proton, neutron and electron calculation, first of all, we have to study about the symbolic represent of atom, because we want to find number of proton, neutron and electron. So, for this study, first of all, we have to understand, right, the symbolic representation of atom. What is exactly the symbolic representation of atom? Atom is denoted by this method. XAZ. What is X? X is a basically symbol of element, right? A is a atomic mass. X is a symbol. A is a atomic mass. Z is atomic number. Atomic number. Now, from this right hand side, upper side, charge will be denoted, and this side atomicity will be denoted. Done. So with the help of this atomic mass and atomic number, we can find numbers of proton, neutron and electron. Which method, sir? Let me study. Let me understand first relation of atomic number and atomic mass. First of all, A, which is your atomic mass. See, in atomic structure, we are going to learn about mass of proton, neutron and electron. Electron are light-weighted among these three. Proton and neutron are slightly heavier than electron. So basically, atomic mass is mass number of proton plus number of neutron. So in simple way, you can write A as proton plus neutron. Proton plus neutron. Sir, then what is Z? What is Z? Z is atomic number. Z is atomic number. Remember one thing, for neutral element, your Z becomes number of proton or electron. But remember this thing, this formula is only applicable for neutral element. If the element becomes charge particle, then this formula going to be changed. This formula of atomic number going to be changed. Remember one thing more, for charge particle, your Z becomes only number of proton. So for charge particle, remember one thing, for charge particle, number of proton is not same as number of electron, because any element, any atom gaining charge by losing or accepting electron. So for any charge particle, number of proton is not equals to number of electron. So sir, for charge particle, how can we find number of electron if it is not same as proton? Wait a second. For charge particle, we are going to study in a short 10 minutes, right? First of all, for neutral particle, remember these two formula, right? From these two formula, we can find number of neutrons becomes, formula of neutron becomes A minus Z. A minus, from atomic mass, if we do subtraction from Z, number of proton plus neutron, if we do subtraction of proton, it remains only number of neutron. So number of neutrons becomes A minus Z. So only these three formulas, 1, 2 and 3, not these. For electron, for charge particle, we are going to study in 10 to 15 minutes. Please wait. Before that, for neutral, that will be clear, right? Let me do one question. Then it becomes smoother for you. See, the question can be asked like this. Find numbers of proton, neutron and electron in 17 chlorine 35. It is a simple formula sum. See, for these, you can straight away write that your A becomes 35, your Z becomes 17. Now, number of protons equals to Z equals to electron. Why? Because it is a neutral atom. No charge is given. Right? So straight away we can say that proton becomes 17 and electron becomes 17. Done, beta? Yes, sir. Clear, sir. Clear. Now, sir, what about the neutron? Yes, we have the simple formula for neutron. For neutron, we have simple formula. Neutron becomes A minus Z. A is your atomic mass, which is 35. Z is your atomic number, which is 17. 17 minus 35, it becomes 18. So, numbers of neutron becomes 18. Number of neutron becomes 18. Done, beta? Now, let we move to the another little bit tougher numerical. Little bit tougher numerical. The question will be, find numbers of proton. Find numbers of proton in 36 gram of water. 36 gram of water. First of all, we have mass of water. First of all, we have to find proton in 1 molecule of H2O. See, first of all, number of proton in 1 molecule of water. It becomes like Z. Hydrogen's atomic number is 1, beta. Each hydrogen atom contains 1 proton. So, twice into Z of hydrogen. It becomes twice into Z of hydrogen plus 1 into Z of oxygen. Twice into Z of hydrogen 1 and 1 into atomic number of oxygen is 8. So it contains 10 proton. 1 molecule of water contains 10 proton. Now, total number of molecules. First of all, total number of molecules. It becomes mole into Avogadro number, beta. And now what is the formula of mole in the terms of mass? Moles becomes given mass upon molar mass into Na will be there. Now given mass is 36. Molar mass of water is 18. So now it becomes twice Na. It becomes twice Na. Now beta, we have a 2 Na as a molecule. So that now total numbers of proton equals to total molecules into number of proton in 1 molecules. In 1 molecule. Done. So now we have total molecules as twice Na. And we have protons in 1 will be 10. So we have 20 Na molecules. 20 Na proton. Right? And if we do simplification, 20 into 6 into 10 to the power 23, it becomes 120 into 10 to the power 23. 120 into 10 to the power 23. Right, beta? 10 protons in 1 water molecules. We have a moles, which is 2 moles. 2 into Na molecules we have. Now, if we have 2 into Na molecules, then it becomes 20 into 6 into 10 to the power 23 protons. Clear? So, we have this much proton there. It's a simple calculation, beta. It's only for a neutral one. Now, the question arises, sir, what will be for the charged particle? Let me move. There will be 2 types of charged particle. There will be 2 types of charged particle. Charged atom, or else if atom is charged, then it is called as charged ion. there will be two types of charged ion present. One is cation, another is anion. See, for cation, remember the spelling and the T. For cation, remember the T. Many of students get confused between cation and anion. So for cation, remember the word T. T becomes positive symbol. So your cation is a positively charged ion and your anion becomes negatively charged ion. Now beta, for cation and anion, for both of them, two formulas will be same. Which two formula? Which two formula will be same? Simple. Number of proton will be same. Number of proton will be Z. For neutral, whether cation or anion, number of proton is Z. But sir, number of neutron, it is also same. Number of neutrons becomes A minus Z. It is also the same one. But what is going to be changed? There will be change in number of electron. What, sir? Number of electron, beta. Remember, number of electron will be changed. Remember, for cation, suppose there will be a X plus. Suppose for the anion, it will becomes X minus. Then numbers of electron for this case will be changed. So for cation, your numbers of electrons becomes Z minus in mode charge. In mode charge. And for anion, numbers of electron, because beta anion is forming by gaining of electron. Cation is forming by loss of electron. How this cation form? If X lose one electron, see, it is forming by loss of electron, and the anion is simply forming by gain of electron. If X gains one electron, it becomes X minus. So it is gain of electron. So here you have to remember, it is loss of electron. So number of electron is Z minus mode of charge. And in this case, number of electron becomes Z plus in mode charge. See, these two formula is very crucial and important. Very crucial and important. If you learn this carefully, your number of electron gets sorted. Gets sorted. Let me do one sum for this. Let me do one sum for this question, so you get clear idea. Find numbers of electron in 17 chlorine 35 minus. 17 chlorine 35 minus. See, we have to find number of electron for this. First of all, 17 chlorine 35 minus. We straight away can write Z equals to 17 and A, atomic mass, becomes 35. Right? Now, number of electron for anion is becomes Z plus mode of charge. It contains minus 1 charge and Z is 17. So 17 1 plus 1, 18. So finally we have numbers of electron as 18. Simple calculation. Simple calculation. Done, beta. Sir, for proton, neutron, it's the same as it is, beta. If they ask number of proton, you can directly write, it becomes Z. So number of proton is 17. So your number of proton becomes 17. Proton is positively charged, so it's 17. Sir, number of neutron, if you have a formula, beta, A minus Z, it becomes 35 minus 17. So numbers of neutron becomes 18. It's a simple. But there will be only change in a number of electron in case of a charged particle. Sir, it is simple for anion, but what about cation? Sir, what about cation? For cation, it have a same counter formula. Instead of this addition, it had subtraction. Let me find. Find number of electron in 3 moles of 11 sodium 23 plus. Oh, sir, this time mole is given. Then we have to find total numbers of electron. Okay, first of all, find number of electron in one ion. Only in a one ion of Na plus, right? For this, formula is simple. We have Z equals to 11, we have A equals to 23. Now beta, number of electron becomes Z plus in mode charge. Z plus in mode charge. What is your Z? Your Z becomes 11 plus what is your charge? Sorry, for cation it becomes, Z minus, right beta? By loss of electron it formed by charge. So minus 1 charge. Plus 1 is given, so 1 charge, 10. So number of electron present in a one ion of sodium is 10. So 1 ion of Na contains, Na plus contains 10 electron. Now it is not our answer because in question we have to find numbers of electron in 3 moles of Na plus. So beta, number of Na ions in 3 moles, it becomes simple beta. Mole into Avogadro number, ions. So moles will be 3 into Na ions. Right beta? Now 1 ion contain 10 electron. So number of total electron in 3 moles of Na plus equals to 10 into numbers of ions. So it becomes 10 into 3 into Na. So we have 30 Na as an answer. Clear beta? So by this method, we simply find numbers of cation, anion also. Done beta? I hope it gets clear now. Now let we move towards the next topic. What is molecular mass and what is molecular formula? So for this topic, first of all, you have to remember remember 1 to 20 elements, their symbol also. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. There are 1 to 20 elements, right? So you have to remember 1 to 20 elements, name, symbol as well as atomic number and atomic mass also. Right? If you get clear idea about that, all things, you get a simple molecular formula for compounds. You can get simple molecular formula for compound. What is molecular formula? When small atoms of a different element combine together in a fixed proportion. Atoms of a different element combine together to form a new compound. elements of a different atoms, their atoms when combined together to form a different compound having a different property than the original element. For example, hydrogen atom, two hydrogen atom and one oxygen atom combined together to form H2O. Hydrogen is a combustible gas, oxygen is a combustion support gas, and H2O is a fire extinguisher. Right? So basically they lose their original property to form some compound, and it is the molecular formula of a compound. It is the molecular formula of compound. See, definition is not going to be asked in your NEET examination, but you have to get the clear idea what is a compound and what is its molecular formula. Right, beta? Now, another question, sir, what is the molar mass? What is the molar mass? Beta, mass of 1 mole of compound, 1 mole of compound, mass of 1 mole of any compound in grams is called molar mass, is called molecular mass or molar mass. Then molar mass. And if mass of one molecule in gram, mass of a single molecule in gram. Another definition, mass of one single molecule in grams, it is called as molecular mass. Molecular mass. Generally we consider both as the same and consider for a 1 mole. So it becomes your molar mass. Done, beta? Let me do some short question from this topic. Find molar mass of sucrose. See, for these molar mass, you have to know its molecular formula. What is molecular formula of sucrose, beta? Molecular formula of sucrose is C12H22O11. Now, beta, what is a molar mass? So, beta, molar mass of sucrose C12H22O11, it becomes 12 into molar mass of carbon, which is 12, plus 22 atom of hydrogen. So 22 into atomic mass of hydrogen plus 11 into atomic mass of oxygen. So it becomes 12 into 12 plus 22 into 1 plus 11 into 16. So it becomes 144 plus 22 plus 176. So finally it becomes 342 gram per mole. Per mole it have a mass which is 342. Done, beta? So by this method we can simply find molar mass of any compound. Now let me move to the another important topic, percentage composition in a compound. What is percentage composition in any compound? Basically, percentage composition is mass percentage of any element in compound. Basically, it is mass percentage of any element in compound. And sir, what is the formula to find this? It has a simple formula. Mass percentage of any element is equals to mass of that element in compound, atomic mass of element in compound into atoms divided by molar mass of the compound, molar mass of a compound into 100, into 100. It is basically formula of mass percentage of any element in a compound. It is a simple formula. If we do one numerical, you get clear idea about it. If we do only one numerical, you got clear idea about it. Let me do one numerical. Find mass percent of calcium, carbon and oxygen in calcium carbonate. In calcium carbonate. Now first of all, what is the molar mass of calcium carbonate? See, 1 into atomic mass of calcium, 1 into atomic mass of carbon, 3 into atomic mass of oxygen. 1 into atomic mass of calcium is 40, 1 into atomic mass of carbon is 12, 3 into atomic mass of oxygen is 16. So beta, it becomes 40 plus 12 plus 16 threes are 48. So it becomes 100 gram per mole. 100 gram per mole. Right beta? Now we have to find mass percentage, or else you can say percentage of composition of calcium. Both the means the same. So mass percentage of calcium in calcium carbonate. It becomes mass of calcium into its atoms, molar mass of, atomic mass of calcium into number of atoms upon molar mass of calcium carbonate into 100. So mass of calcium, atomic mass of calcium is 40 and the number of atom present is 1 divided by molar mass of calcium carbonate is 100 into 100. That 100 gets cut. So there will be 40% calcium present in calcium carbonate. It is called mass percentage beta. It is called mass percentage. Now beta, what is mass percentage of carbon? It becomes atomic mass of carbon into atoms divided by molar mass of calcium carbonate into 100 into 100. So beta, we get a clear idea. Molar mass of carbon, atomic mass is 12, one only carbon atom is present upon 100 into 100. So it becomes 12%. Now beta, last thing, mass percentage of oxygen. It becomes atomic mass of oxygen into atoms divided by molar mass of calcium carbonate into 100. So what is atomic mass of oxygen? 16. But there are 3 atoms of oxygen present divided by 100, which is atomic mass of molar mass of calcium carbonate into 100. So we get 48%. So you can simply cross verify your answer by addition of these all mass percentage. And if it becomes 100, then your answer is absolutely correct. Done beta? So it is basically percentage composition of any element in compound. Done beta? Okay, let me move towards the another concept, which is empirical formula and molecular formula. See beta, what is empirical formula? What is empirical formula? And what is molecular formula. See, empirical formula is the smallest ratio of element present in the molecular formula. Empirical formula is the smallest ratio formula which is present in molecular formula. Sir, it is a very tough definition. Yes, I know. Yes, I know it is a tough definition. Just forget about definition. Just forget about definition. We all know what is a molecular formula. It is the actual formation of compounds by joining of numbers of atoms of different element. We all know that it is a fixed proportion element combined to form a particular formula which we call molecular formula, right? For glucose, we all know that for glucose we have the molecular formula as C6H12O6. It is a molecular formula of glucose. When 6 atom of carbon element combining with the 12 atom of a hydrogen element and 6 atom of a oxygen element, we have molecular formula of glucose, right? Now what is empirical formula of glucose? Let me move this side. What is empirical formula of glucose? See, basically empirical formula is simple ratio of combining elements. From these ratio, you can see straight away that one carbon is combined with the 2 hydrogen and 1 oxygen. What we do here to get the simple ratio? Let we took some common whole number as a common. So here we can take 6 whole number as a common from this formula. So here we get simple ratio. 1 carbon combining with 2 hydrogen and 1 oxygen. So it becomes your empirical formula. Okay, sir. It's too much simple. Yes, we have to just take common whole number from molecular formula to get empirical formula. And sir, is that any such relationship between molecular formula and empirical formula? Yes, my dear student, we have some relation. Yes, we have some relation. Yes, and what is relation? Molecular formula is whole number. Here n is not mole, it's simple small n, which is whole number into empirical formula. Yes, molecular formula is whole number into empirical formula. Sir, from where we can get the whole number? Please wait, my dear. You will get to know about the whole number in next upcoming 10 to 20 minutes. Yes, but sir, yes, basic idea is clear, sir. Sir, one more thing, please. We observe that in the both the case, the element combining ratio is same. Yes, same beta. So in this both the formula, we get percentage of composition will be same. Yes. So make one more key line, which is your KKC, Karthik sir's key concept. Yes, percentage of any element in empirical formula and molecular formula. For same compound. will be same. Sir, that means percentage of carbon in CH2O and C6H12O6 will be same. Yes, my dear, it will be same. It will be same. Basically, what is this percentage? It is mass percentage or percentage of composition. Done, beta. So it is a golden line from where you can solve your NEET MCQ in seconds, in just seconds. So please make sure do write this formula in your notebook. Done. Now let me discuss one of the example of this empirical formula example. Let me write the question. Let me write the one simple question based on the empirical formula. A compound contains element A with mass percentage. A compound contain element A with mass percentage 80. Molar mass of A will be 20 gram per mole and element B. A compound is made with the two element A and element B. Element B by mass percentage of 20, right? So total will be 100. So there will be no third element in the compound, right? And now again molar mass of B would be 10 gram per mole. 10 gram per mole, right? Find empirical formula of following compound. Find empirical formula for following compound. See, for these type of sum, you have to made a table from which we can find empirical formula. A table made with the 5 columns, element, moles, ratio, simple ratio and whole number. See, in this table, first thing is element. Second is mole. Second thing is mass percentage. Second thing is mass percentage. Third thing is a mole. Fourth thing is a simple ratio. And the last one is whole number. By these we can simply find molecular formula of any or empirical formula of any compound. See, first of all there will be a two element present here, element A and element B, right? Mass percent of a element A is a 80 while mass percent of element B is a 20. What is a mole? Now this mass percent considered as a mass, and what is molar mass, which is given as a 20. So basically moles can be found with the mass percent divided by molar mass. So 80 divided by 20 becomes 4 and this 20% divided by its molar mass 10. So this becomes 2. So now what is simple ratio? Among the mole, which one is the smallest? Consider the simple ratio with the smallest one. For example, it becomes 4/2 and here it becomes 2 by 2. So now 4 by 2 means 2, 2 by 2 becomes 1. So the nearby whole number is same as this. If we get answer in a decimal values, then you have to do round off for a whole number. Done beta? Now what is the empirical formula beta? So here with the help of this table we get is empirical formula, and the empirical formula will be A to B. 1 A to B1, but if you write 1 is good or not write 1, it's also good. No need to write one number. Done beta? So finally we get your empirical formula and it's A to B. Clear? So by this table where we used to find these 5 different columns, right? Element, mass percent, mole, simple ratio and the whole number. By these method we can simply find beta the empirical formula of any compound. Let me move towards the some of the MCQs based on the following topic, right? Let me discuss some of the important MCQ based on these all following topics. First question, find the number of hydrogen atoms in 36 gram of a water. See here in this scenario we have to find number of hydrogen atoms, right? So for atom, first of all we have to find number of molecules. So from mass we can get number of molecules. If 18 gram of H2O contains Na molecules, right? Molecules as Avogadro numbers, then 36 gram of water contains how many molecules? Simple cross product ratio available here. So beta it becomes 36 into Na divided by 18. So it becomes 2 Avogadro number, 2 times of Avogadro number molecules of water. But here in this scenario we have to find number of hydrogen atoms beta. So hydrogen atom will be 2 per molecule. So I can write that total number of hydrogen atoms will be twice into number of water molecules. Number of water molecules beta. So it becomes twice into number of water molecules is 2 times Na. So it becomes 2 into 2 times Na. So it becomes 4 times Avogadro number. So sometime in option answer will be in a Avogadro number form. So you have to choose the correct answer only without doing a simplification. So your correct answer is beta 4 Na. Done. Let me move towards the another MCQ beta. Another question, how many silver atom present in 100 gram of a silver rod with 90% purity? See beta, whenever purity is given you have to do some extra step. Let me begin. The silver rod is a 90% purity with 10 gram. So beta we have to find first of all mass of a pure silver. So I can write that if 100% purity there will be 10 gram of Ag, but now the purity is 90%. Then how many gram of pure Ag present? Pure Ag present. So first of all you have to find the mass of pure Ag. So mass of pure Ag becomes 10 into 90 divided by 100. So we got 9 gram. So finally we got 9 gram of silver, right? So mass of Ag is given. Now we have to find silver atoms. So for this we have to find its moles. So moles of Ag becomes mass upon molar mass beta. What is the mass of Ag? 9. divided by 108. It is its molar mass. We have to do simple calculation, or else we can put the same as follows, right? Now beta, number of molecule. Ag is a monoatomic molecule. Ag is monoatomic molecule. So we can find directly number of Ag atoms directly as same formula of molecules. Moles into Avogadro number. What is the moles? It will be 9 divided by 108 into 6.022 into 10 to the power 23. Done beta? Into 10 to the power 23. So you have to do this simple calculation right now. For time saving purpose, I am going to use calculator, but you have to do it by taking a round off. This 6.02 considered as a 6. Then also you can get the answer. Let I discuss. 9 into 6 divided by 108. So it becomes 0.5 nearby. Right beta? 0.5 nearby. So 0.5 into 10 to the power 23. 0.6 into 10 to the power 23 is your correct answer, or else you can shift one decimal to the right hand side. One decimal to the right hand side. In that scenario, you can get exact answer 5.0 into 10 to the power 22. So 5.0 into 10 to the power 22 is your correct answer. Done beta? So it is a simple method to find with the purity, help of purity. For the purity case, you have to do this extra step. Done? Let me move towards the next question beta. What is next question? Find the numbers of sodium atom in 92 gram of a sodium metal. Again we have to find number of atoms, and we have 92 grams of a sodium. So basically moles become mass upon molar mass. Mass of sodium is given as 92. Molar mass of sodium is 23. Right? So we have a moles which is equals to 4 moles. Now again I am writing the same line again which I wrote in a silver case. Na is monoatomic. So number of molecules and atom will be same. So number of sodium atoms will be moles into Avogadro number. What is moles? 4 into Na. So correct answer is 4 times Na. And yes, you can see in the option 4Na. Done beta? Let me move towards the next question beta. A compound contains 78% of carbon and 22% of hydrogen. What will be its empirical formula? Again, for empirical formula, we have to make a table with the 5 columns in it. In first column, we mention element. In the second column, we mention mass percent. In third column, we mention moles, element, mass percentage, which later considered as a mass. Third one is the moles. Fourth one is a simple ratio. And the fifth one is a whole number. Done beta? Now here 2 elements are given. One is carbon and another is hydrogen. For carbon 78% is given. For hydrogen 22%. Now moles become 78 by atomic mass of carbon, it's 12. So 78 divided by 12, and for hydrogen 22 divided by 1. 22 divided by 1. See, 12 6 are 72 and it's 78, means it will be a 6.5, and here it will be a 22. Which one is the smallest? This one is the smallest. So here 6.5 divided by 6.5 and the 22 divided by 6.5. Clear? So here we get a 6.5 divided by 6.5 becomes 1. 6.5, 22 divided by 6.5. Probably it would be a 6 3s are 18. It was 6.5 3s are 19.5. So here we get something 3.3 something, right? 3.3 something. So nearby whole number of these as on round off 1 and 3. So our empirical formula becomes C1. So C and H becomes 3. So our empirical formula becomes CH3 beta. So your correct answer is CH3. Done beta. For these type of MCQ, first of all in this video you have to pause it and do calculation by yourself, and then after it match your answer with mine. Done. Let me move towards the next MCQ. Pause the video, yes, and solve this question by yourself. Then gets answer, and then after it match your answer with mine. Done. Let me move towards the next question. What is the next question beta? 0.1 kg of a limestone having a purity of 50%. See, again the purity question asked. Find number of atoms of oxygen in it. What is the formula of limestone beta? Calcium carbonate is known as a limestone, right? It has a 50% of purity. So we can directly find that if there will be 100% purity, then there will be a 0.1 kg. That means 100 gram of calcium carbonate present. But if the purity is 50%, then how many gram of calcium carbonate present? So simply 100 into 50 divided by 100. So we get 50 gram of calcium carbonate. Now for atoms of oxygen we have to find number of CaCO3 molecules. Molecules beta. So for molecules we have formula moles into Avogadro number, and from mass we can find mole by mass upon molar mass. See, mass pure calcium carbonate is 50 grams divided by beta molar mass of calcium carbonate. Calcium molar mass is 40, carbons is 12, oxygen is 16. Atomic mass 16 3s are 48, 48 plus 12. 48 plus 12 it becomes 60, 60 plus 40 it becomes 100 gram per mole, right beta? So finally divided by 100 into, see answer is in terms of Na, so we have to put Na here. So finally we have number of calcium carbonate molecules, number of CaCO3 molecules. It becomes, see, 100 2s are 50, 1 by 2 becomes 0.5. So it is 0.5 Na. Now beta we have to find oxygen atoms, right? So number of oxygen atoms, see there will be 3 oxygen atoms. So 3 into number of CaCO3 molecules. So 3 into 0.5 of Na. So it becomes 1.5 Na. 1.5 Na. So your correct answer is option number B, 1.5 Na. Done beta. Let me move towards the next MCQ. How many nitrogen atom present in 11,200 ml of nitrogen gas at STP? From volume we have to find atom. So it's a simple formula. First of all, convert this volume in liter. So 11,200 ml, if you convert in liter, do it divided by 1000. So instead of ml it becomes liter. 3 decimal cut, it becomes 11.2 liter at NTP. Done beta. Now you can write that number of nitrogen atom, we can say number of molecules. If at NTP 22.4 liter of N2 gas contains Na molecules. Na molecules. So now we have at NTP 11.2 liter of nitrogen gas that contains how many molecules? So finally by this method 11.2 into Na divided by 22.4. So here we get 0.5 Na molecules. But see beta, nitrogen is a diatomic molecules. One molecule of nitrogen contains two atoms because we can write N2, right? So it is diatomic molecule. So after this, number of nitrogen atoms, it becomes 2 into number of N2 molecules. Done beta. So twice into 0.5 Na. So it becomes Na atoms. So nitrogen contains one Na or Na atoms. Done beta. It's a simple question. Yet another mole concept. Important question. Now let me move towards the next question. Which of the following have highest numbers of atoms present in it? In this scenario, we have to find which of the following contains highest number of atom. First of all, for atom, we have to find all of them's moles. What is glucose beta? It is C6H12O6, right? What is sucrose? C12H22O11. What is water? H2O. What is CO2? CO2. Done beta. For glucose, let me find its moles. So moles becomes mass upon molar mass. And what is the mass of glucose given? 180. And yes, we all know that molar mass of glucose is also 180 beta. So it becomes 1 mole. Done. Now for moles of a sucrose, again moles is equals to mass upon molar mass beta. What is mass? 342. Molar mass is also 342. 1 mole. Again same case in water. 18 mass is given. Molar mass is also 18. So it's 1 mole. And for CO2 also, moles equals to mass upon molar mass. 44 mass is given. Its molar mass is also 44. So 1 mole. So now beta, we have same moles of all. So now let me see the numbers of atom. 1 mole, so molecule will be same. Na molecules. In each there will be Na molecules. Because 1 mole contains Avogadro number like molecules. But for atom we have to find out which molecule contain maximum numbers of atom. Here in question they have asked highest or maximum numbers of atom. So glucose contain total 24 atom. So here 24 Na atoms present. For these 12 plus 22, it becomes 34. 34 plus 11, it becomes 45. So here it becomes 45 Na. See, there will be a 45 Na present here. In H2O 3 atoms only present, so 3 Na. In CO2 1 carbon 2 oxygen present, so again 3 Na. So which one contains highest atom? Option number B, 342 gram of a sucrose can contain highest numbers of atom. Done beta. Let me move towards the next question beta. Which of the following has highest numbers of water molecules? See, first is simple, 18 molecules. So it's 18 molecules. Now second one, 1.8 gram of water. So moles becomes 1.8 divided by 18. So it becomes 0.1 mole. And for that, number of molecules beta is equals to moles into Avogadro number. And what is mole here? 0.1 into Avogadro number, right? Again 18 gram. So we know that it's a 1 mole beta. It's 1 mole. So in that case, number of molecules becomes Na. Na. And for the next case, 18 moles of water. Already directly moles is given. Now beta, number of water molecules equals to moles into Avogadro number. So it becomes 18 Na. So you can see clearly, it's only 18 molecules. It's 0.1 Na, 0.1 into 6.022 into 10 to the power 23. Here it is Na. So it is 6.022 into 10 to the power 23 and it's 18 time of Na. So this one contains highest maximum numbers of water molecules. This type of the question asked a few times in a previous years of the NEET question. So it is important MCQ, make them as a KKC, key concept. Karthik sir's key concept. Done beta? Let me move towards the next question beta. One unknown gas having a 7 gram of mass, having a volume 5.6 liter at STP. Find that unknown gas. See, here we have the mass at 5.6 liter. If we can find mass of 22.4 liter gas, it is same as its molar mass because it is for 1 mole. So I can write that 5.6 liter of gas at STP contains 7 gram. Right? So if 22.4 liter of gas at STP contains how many grams? So straight away 7 into 22.4 divided by 5.6 divided by 5.6. So here it becomes 4 times and 7 fours are 28 gram. So now mass of 1 mole becomes its molar mass beta. So molar mass of unknown gas is 28 gram per mole. Now we have to find which of the following gas have molar mass equals to 28. So now beta, molar mass of O2. See, molar mass of oxygen atom is 16. So O2 becomes 32. So it is the wrong option. Right? 32 gram per mole. It is the wrong option. Molar mass of helium is 4 gram beta. 4 gram per mole. So it is another wrong option. Molar mass of hydrogen gas 2 into 1. So it becomes 2. So it is the wrong option. So none other than D option is right. Molar mass of N2. Nitrogen's molar mass is 14. 14 2s are 28. So yes, unknown gas have the molar mass 28. So the correct option is our nitrogen gas. Clear beta? It is simple sum. Let me move towards the next question beta. One polymer contains 36 gram of a carbon, right? Find the least molar mass. See, there is a one correction here. Find the least molecular mass. The least molar mass of a polymer in gram per moles. See, what is the formula of mass percentage beta? Mass percentage equals to atomic mass into atoms divided by molar mass into 100, right? It is the formula for any mass percent of any element in compound. So one polymer contains 36 gram of a carbon. So here I am taking as 36 percentage of carbon. Atomic mass of carbon is 12 minimum. So at least there will be one atom of carbon present here. So into 1 divided by molar mass beta into 100. So if we are making a molar mass as a lead, it becomes 12 divided by 36 into 100. So 12 3s are 36, 100 divided by 36, it becomes 33.33 gram per mole. It becomes 33.33 gram per moles. So our correct option is option number B. Done beta? Let me move towards the next question beta. Yes, question is done. Now let me discuss what is average atomic mass. For average atomic mass, first you have to understand the concept of isotopes. What is isotopes? What is isotopes? See, isotopes are the elements having the same atomic number but different atomic mass. Isotopes are the element having same atomic number but different atomic mass. See, carbon have a 3 isomers. 6 isomers of a carbon. See, isomers or isotopes of carbon. So 6 carbon 12, 6 carbon 13 and 6 carbon 14. See, here for these 3 isotopes, they are having a same number of atomic number, but they possess different atomic mass. See, their atomic number will be 666, but their atomic mass is 12, 13, 14. So you can say that number of proton will be same. In all, number of proton will be same. 6, 6, 6. Number of neutron will be different. 12 minus 6. Number of neutrons formula we all know that it's A minus Z, right? So number of neutrons will be 12 minus 6, it becomes 6. Here in this case 13 minus 6, it becomes 7. 14 minus 6, it becomes 8. Sir, if we can find these 3 type of carbon here, why atomic mass of carbon taken as 12? Why not 13 or 14? For that beta, you have to understand average atomic mass. Whenever in nature more than one isotopes of any element found, then its atomic mass is taken as average atomic mass. Then again sir, one question arises. If you are taking average atomic mass, the average of 12, 13 and 14 becomes 13. Then why we are going to take atomic mass of carbon as 12? Because beta, these percentage not only can find with the atomic mass, but here for finding average atomic mass, we have to consider, for finding average atomic mass, we have to take consideration of their natural abundance. Depend on natural abundance. That means in nature, if we get 100 atom of carbon, how much atom of carbon 12 we found, how much atom of carbon 13 we found, and how much atom of carbon 14 we found. So here in exam, they gave you a table like this. Element and natural abundance. So by help of this table, you can find average atomic mass. By which method, sir? Wait a second, Munna. There are three types of carbon: 6 carbon 12, 6 carbon 13, and 6 carbon 14. The natural abundance of 6 carbon 12 is 99.9 percentage. 99.9 percentage. 6 carbon 13 is 0.001 percentage, and this one is 10 to the power minus 6 percentage. Sir, we have to remember the natural abundance. No, beta, that will be given you in the questionnaire data form. Now from these data you have to find average atomic mass. Sir, then what is the formula of average atomic mass? The formula is simple, beta. The formula is very simple. Sigma, the algebraic sum of atomic mass into natural abundance divided by, see here, atomic mass 12 should be multiplied with 99.9, 13 should be multiplied with 0.01, and 14 should be multiplied with the 10 to the power minus 6 divided by 100. Sorry. Done. So by which method we can find? See, let me do this algebraic sum. 12 into 99.9 plus 13 into 0.001 plus 14 into 10 to the power minus 6 divided by 100. So if you solve this sum, if you solve and do it a calculation, it is near about 12.001. So we are consider this as a 12. So finally we get the atomic mass of carbon, average atomic mass of carbon, and it is nearby 12. And it is nearby 12. Done, beta? I hope it gets clear now. Let me move to the next topic, which is very important topic, which is vapor density. For vapor density, we all know the simple formula of density first of all. Before understanding vapor density, let me understand what is simple density. In physics, you learn this topic already. What is density? Sir, density is the ratio of mass versus volume for any element. Density denoted by the rho or D. Yes. So density becomes mass upon volume for any element, compound, etc. So sir, density we all know that, mass upon volume, and sir, even unit also we know that. Unit of density is gram per ml, or else you can write kg per liter, etc. Done, beta. Basically it is mass upon volume. Then sir, what is this vapor density? Beta, whenever density of any gas measure with respect to hydrogen gas, when density of any gas is measured with respect to hydrogen gas, it is known as vapor density. Clear, beta? When we measure density of any gas with respect to hydrogen gas, basically if I am talking about vapor density of methane gas, So it becomes beta, it becomes simple density of methane gas upon density of hydrogen gas. It is a simple ratio, right? Density of methane gas with respect to density of hydrogen gas. See, for this vapor density, this formula is useful, but from this formula we can derive one important statement, and please make them as KKC. Make them formula as KKC. That is a key concept. Yes, and the statement is not the formula, the statement is vapor density. Vapor density is unitless. Why, sir, vapor density is unitless? Because beta, density upon density becomes unitless, right beta? One another formula for vapor density which we are going to prove that the vapor density of any gas, vapor density of any gas at STP becomes molar mass of this gas divided by 2. Huh? How, sir? What is the relation between vapor density and molar mass, sir? Yes, relation between vapor density and molar mass is molar mass of gas divided by 2. But sir, how this formula actually comes? Let me discuss. Let me discuss another point of vapor density. Vapor density in terms of molar mass. Let me discuss vapor density in terms of a molar mass. For this, we all know that ideal gas equation. From ideal gas equation. What is ideal gas equation, beta? Basically, this equation is from class 11th, right? Deleted topic. Because basically states of matter is now deleted topic, but this equation is very useful. This will comes in all topic of thermodynamics, equilibrium, in everywhere. So please remember the formula. Ideal gas equation suggests us that PV equals to nRT, where P becomes pressure, V becomes volume, N becomes your mole, R becomes the gaseous constant, T becomes temperature. So for these formula, we can write that PV equals to, instead of mole, we can write mass upon molar mass into RT. Right beta? Mass upon molar mass into RT. Now beta, let we make molar mass as a lead. So your molar mass becomes mass upon volume into RT by P. Sir, why mass upon volume you separated here? Because beta, mass upon volume becomes your density. So molar mass equals to density into RT by P. Now beta, do understand, at STP, temperature and pressure becomes constant, and here your R is also a gas constant. So beta, at STP you can directly tell that molar mass directly proportional to, at STP you can directly suggest that molar mass directly proportional to density. Molar mass directly proportional to density. Now beta, what is vapor density? Vapor density is a ratio of any unknown gas density upon density of hydrogen. So beta, I can write that vapor density of any gas is equals to density of gas upon density of gas upon density of hydrogen. Yes or no? Yes sir. We can say that. Now beta, density directly proportional to molar mass or molar mass directly proportional to density. So here instead of gas density upon density of hydrogen, we can write that molar mass of gas upon molar mass of hydrogen. And we all know that molar mass of gas is maybe unknown thing, but molar mass of hydrogen we all know that it will be a 2 gram per mole. 2 gram per mole. So finally see here from this formula, instead of these two density, we can write molar mass of gas by 2. So vapor density of any gas becomes molar mass of this gas divided by 2. Done beta. So this formula is proved. Clear beta? It is most important formula for finding molar mass of any gas with respect to its vapor density. Clear? Let me move towards the next target. See the question based on this topic, vapor density. If the ratio of vapor density of two gases are 1:8. See, vapor density of A is to vapor density of B is 1:8. If atomic mass of A is 16 gram per mole, what is atomic mass of B? See beta, vapor density's formula we all know that. Suppose I am taking vapor density of A, it becomes molar mass of A divided by 2 with ratio of vapor density of B. It is molar mass of B divided by 2. Now beta, we have the vapor density of A is to B are 1:8. And these 2 gets cuts. So basically 1:8 becomes molar mass of A upon molar mass of B, atomic mass of A upon atomic mass of B. Done beta. So now simple, we have atomic mass of A which is 16. So here your 1/8 is equals to 16 upon mass of B. So beta, atomic mass or molar mass of B is 16 which is equals to 128. So 128 gram per mole. Done beta. So the correct option is option number D, 128 gram per mole. Let me move towards the next thing. Next thing is most important thing. Stoichiometry and stoichiometric coefficient. Beta, one question will be definitely asked from this segment. It is the most useful segment, most useful segment for upcoming NEET examination. NEET 2025. Done beta. What is stoichiometry and what is stoichiometric coefficients? Beta, stoichiometry means whenever any chemical reaction occurs, some part of a reactant will be consumed and simultaneously some part of a product will be formed. So the calculation of consumed reactant or remaining reactant and calculation of produced product, these all calculation belongs to stoichiometry. And what is stoichiometric coefficient? The mole part in a balanced chemical region, and a mole part in a balanced chemical reaction, the mole part will be known as stoichiometric coefficient. So for stoichiometry and stoichiometric coefficient, first there is a one important rule, and the rule is first balance chemical reaction for stoichiometry and stoichiometry coefficient. Done, beta? First thing, you have to balance the chemical reaction. Let we begin stoichiometric calculations with easiest chemical reaction. Combustion process of any haloalkane. Let me take the first simple example, chemical reaction of combustion of methane gas. Whenever methane gas is combusted in the air, we have oxygen as a combustible gas. It can combustible gas and it can do combustion process with a methane to produce carbon dioxide and water vapor. So for these reaction, first of all, we have to balance this chemical reaction, and simultaneously we also have heat plus light, which we are not calculating in the stoichiometrical chemical balancing reaction, right? So one carbon at left hand side, one carbon at right hand side, balanced. Already you are doing this balancing from standard 10th, right? Here we have a 4 hydrogen, but here in this side we have only 2 hydrogen. So here multiplying with it 2. Now for oxygen we have only 2 oxygen here, but in the right hand side 2 plus 2, 4 oxygen. So here we can multiply 2, so 2 2s becomes 4. So now it is your balanced chemical reaction. Now for stoichiometrical calculation, let me make some simple table. By these balanced chemical reaction, which are the things which we can find with stoichiometric calculations? There are few things which we can find easily. First is moles, second is mass, third is volume of gas, fourth is number of molecules, and the fifth one is number of atoms. So from these things we can easily find 5 different things. Done. Come on. Now first thing, number of moles. Methane, there will be no stoichiometrical coefficient, so it will be 1 mole of methane. There will be a 2, so here it will be a 2 moles of oxygen gas. Here there will be nothing in front of carbon, so it becomes 1 mole of CO2. Again there will be 2 mole here considered as a stoichiometric coefficient, so it is 2 mole of water molecule, right? Now from this number of mole we can find many things: the relation of mole with mass, the relation of mole with volume of gas, the reaction of mole with molecules, and also atoms. So first of all, let me find mass. So here 1 mole of CH4. What is molecular mass of CH4? 12 plus 4, 16 gram. So 16 gram of methane combined with 16 2s are 32. Molar mass of O2 gas is 32. Molar mass of oxygen is 16. 16 2s are 32. 32 2s are 64 grams. Right? 16 gram of methane combined with 64 gram of oxygen to produce carbon dioxide 1 mole. So its molar mass will be 44 gram. 12 plus 16 2s are 32. 12 plus 32 becomes 44 gram. Twice into H2O. H2O's atomic mass is 18. 18 2s are 36 grams. Done beta? Done beta? So here we have the mass, and see, for checking whether you are balancing correctly or not, check the total mass. 64 plus 16, it becomes 80. 44 plus 34, 6, it becomes 80. So your chemical reaction is balanced. Done? From mass now we can find volume also. Volume at STP. It is only useful for gas. Volume at STP. It is only for gaseous things. 1 mole here, so its volume is 22.4 liter. 2 mole here gaseous state, so its volume becomes 22.4 2s 44.8 liter. Here 1 mole again, so its volume becomes 22.4 liter. Here 2 moles, so volumes becomes 4, but it is in a liquid state, so volume, we can't find volume of water. So please make that as a dash because it is in a liquid state. Done? So these are the things which we can find with the balanced chemical reaction. Now the next part, number of molecules. Number of molecules. See, number of molecule, 1 mole of CH4 present, so 1 into Na. Number of molecules of O2, 2 moles, so it becomes 2 into Na. Here 1 mole of CO2, it becomes 1 into Na, and here 2 moles of H2O, so it becomes 2 Na. Done beta? Now the last thing, number of atoms. Last thing, number of atoms. Total atoms, right? You can find individual also, but let me discuss number of total atoms. 1 molecules of methane contain 5 atoms. 1 carbon, 4 hydrogen. So 5 into number of molecules, which is 1 Na. So 5 into 1 into Na. For this, there will be 2 atoms per oxygen molecule. 2 atoms per oxygen molecule. So 2 into number of molecules, which is twice Na. So it becomes 4 times Na. It becomes 5 times Na. And now for CO2 there will be 3 atoms present. So 3 into 1 into Na. So it becomes 3 Na. It becomes 3 Na. Now for this there will be 3 atoms of oxygen present. So 3 into number of molecule, which is 2 times of Na. So it becomes 6 Na. See, there will be total number of molecule atoms also same. 5 plus 4. 5 plus 4, 9 Na. 6 plus 3, 9 Na. Clear beta? So by this amazing table, you can find all the things. You can find all the things. Done? It is your balanced chemical reaction and it is all the stoichiometric calculation. Read it carefully and write down. Done beta? Let me solve one more example of this stoichiometry. The concept is clear. Now let me do one more practice. Let me take another example for this type of questions. Reaction of nitrogen gas with hydrogen gas to produce ammonia. It is called Haber process. So in this Haber process, we are going to do reaction of nitrogen gas with hydrogen gas to produce ammonia. And let me make one stoichiometric table for this type of this reaction, right? In this reaction again we are going to calculate the 5 things: moles, then mass, then after moles and mass we are going to calculate number of atoms and molecules, right? Molecules and atoms. See, let me begin with the moles, but before we start stoichiometrical calculation, remember one thing: we have to balance this chemical reaction, right? Here on this side 2 nitrogen present, so here 1, so here we make it 2 nitrogen. Now the hydrogen on the left hand side is 2, but on the right hand side 3 2s are 6. So here we are balancing with the 3 moles. Now from these reaction you can say that 1 mole of nitrogen gas reacting with the 3 mole of hydrogen gas to produce 2 mole of ammonia gas. Simple in words, right beta? So please mention your physical state, gaseous state, and it is also in a gaseous state as well. Now let me write the components. First is mole, second is mass, third is volume at STP. Volume at STP. Fourth is number of molecules. Sixth is number of atoms. And here we can do some calculations, right? Now the remaining part, after moles, mass, number of molecules. Done. Let me begin it with the moles. We can clearly see that 1 mole of nitrogen reacting with the 3 mole of hydrogen to produce 2 mole of ammonia. Now mass, atomic mass of nitrogen is 14. So N2 will be 28 grams. Atomic mass of hydrogen is a 1. So it will becomes 1 2s are 2 and there will be 3 moles. So 2 3s are 6 grams. And now for ammonia, 14 nitrogen, 3 hydrogen, 14 plus 3, 15, 16, 17, 17 2s are 34. Now you can clearly see that, let me do one more thing, 28 plus 6, it becomes 34. Total mass of reactant will be always same as total mass of product. Done? So your chemical reaction is balanced. Now volume at STP. If there will be 1 mole, then it will be a 22.4 liter. Here it is a 3 mole, so it becomes 3 into 22.4 liter. Remember, in volume of gas, there will be no addition. So volume of reactant is not equals to always volume of product. Please make sure. But mass will be the same. Now, volume of product will be 2 into 22.4 liter. Done? Now, number of molecules. There will be a 1 mole of Na present. So, number of Na molecule, 1 mole of nitrogen will be Na. 3 mole of hydrogen. So, molecules of the hydrogen will be 3 times of Na. And 2 moles of Na. So, molecule NH3. So, 2 into Na. Avogadro number. Now, beta, what is the number of atoms? See, nitrogen is made with the 2 atoms. 2 atoms. So, it is 2 into Na. 2 into number of molecules. Hydrogen is made up with the 2 atom. So, it becomes 2 into number of molecules. So, 2 into 3 Na. And ammonia is made up with the 4 atom. 1 nitrogen plus 3 hydrogen. So, 4 times number of molecules, which is twice Na. So, the total numbers of atom, twice Na of nitrogen, 6 Na of hydrogen, and total atom of in ammonia will be 8 Na. So, atoms also will be the same. Done of reactant and product. So, this is a basic calculation all done. Now, what type of question will be asked? So, the question will be asked like this. In production of ammonia, gas, See, all questions are based on this reaction, right? If we use 3 moles of nitrogen, 3 moles of nitrogen gas, then how many moles of ammonia produce? How many moles of ammonia produced? Ammonia produced. Beta, simply, first of all, for this type of sum, you have to write balanced chemical reaction, right? Nitrogen gas is combining with the hydrogen gas to form ammonia, and for balanced chemical reaction you have to do balancing first of all. So here it comes 2 to 3 are 6, so for hydrogen it becomes 3. Done. Now what two values? One is given and one we have to find. Which are these two? N2 and ammonia. So make underline between them. And what is the given data? Write first of all given things. Given thing is 1 mole from reaction, 1 moles from given, or you can say it from stoichiometry. Stoichiometry suggests that 1 moles of N2 can produce 2 moles of NH3. Now what is in a given data? So in a given data we can use 3 moles of N2. So by 3 moles of N2, how many moles of NH3 produced? NH3 produced. Done beta? Simple cross product, just we have to apply it. So basically 3 2s are 6 divided by 1. So 6 moles of NH3 produced. Done beta? It's a simple numerical based question. Let me discuss one more question of this type, stoichiometry and stoichiometric calculation. They can ask mass as well as they can give volume and ask in mass as well as. Let me do one or two more examples so it get clear. Question number 2. In production of ammonia is same in all question. In production of ammonia, if we use see, for these reaction we are talking, so if we use 7 gram of ammonia, 7 gram of nitrogen, sorry, how many grams of NH3 formed? See, now here we are discussing about gram to gram calculation, right? So these sum can be done by 2 methods. One is lengthy method and one is smart Karthik sir's key concept method. First of all, let me discuss some lengthy method. Yes, for stoichiometrical chemical reaction, you have to write balanced chemical reaction first. N2 plus 3H2, it gives twice NH3, right? Done. Now beta, what is given? In given data, you have mass of N2 gas. Mass of N2 which is given as a 7 gram. And what is molar mass of N2? It will become 14 2s, 28 grams per mole. So by these data, you can find mole of nitrogen, and which is mass upon molar mass. Mass is 7, molar mass is 28, 1 by 4, so it becomes 0.25 moles. Done. First of all, you have to find the moles, right? And it's a simple thing, mass upon molar mass. Mass is 7 gram and molar mass of nitrogen is 28, so it becomes 0.25 mole. Now beta, with this equation, you can say that from reaction, from stoichiometry, compare the moles of nitrogen versus moles of ammonia. So we can write that 1 mole of N2 gives 2 mole of NH3. 2 mole of NH3. So we have given data. We have given such quantity in question that 0.25 moles. 0.25 moles of N2. We get how many moles of NH3? From 1 mole we get 2 moles, then 0.25 moles of N2. How many moles of NH3 form? So beta, moles of NH3 becomes cross product 2 into 0.25 divided by 1. So it becomes 0.50 mole. Done beta? So now we have moles, but in question they asked how many grams of NH3 form. So we have to find mass of NH3. For now, mass of NH3 becomes moles into molar mass. We have the formula, right beta? So it becomes moles into molar mass. What is the mole? 0.50. And what is the molar mass of NH3? 14 plus 3, 17. So 17 by 2, 8.5 grams. 8.5 grams. It is your answer. Now sir, we have to do such a long calculation, converting mass into moles, then stoichiometry, and then again moles to mass. It is a lengthy process. So do we have any shortcut KKC? Yes, my dear student, we have a shortcut. By which method only in a 4-5 lines you get the correct answer. So please give us yes beta. It is for you only. KKC, Karthik sir's key concept. We can directly convert mass to mass. Let's compare their molar mass. N2 plus 3H2, it gives twice NH3, right? Let you write mass below that equation. Mass of them below that equation. Nitrogen, it's 28 grams. 28 grams of nitrogen can produce mass of these asked in question. Okay, mass of these 17 2s 34 grams of NH3. 34 grams of NH3 straight away. So sir, now directly write as a stoichiometry as this 28 grams of N2 produce 34 gram of NH3. Directly write it down. Now in question we have 7 gram of N2. From 7 gram of N2, how many grams of NH3 produced? Directly, do it directly. 7 into 34 divided by 28. 7 into 34 divided by 28. 7 4s are 28. 34 divided by 2, which is 17 by 2, which is 8.5 grams. Only in 2 lines. Only in 2 lines you get answer. So it is a KKC where you get 4 marks in your upcoming NEET examination in only few seconds. What is KKC? KKC is a magic where your hard, difficult MCQ becomes easier and gets solved in only 1 line or 2 lines. It is KKC, the power of KKC. Done beta? Let we move towards the more questions of this type. Let we do practice of more questions of this type. Why sir? Beta, because most of the time the question will be asked from the stoichiometry or stoichiometric coefficient in your upcoming NEET examination. Let we do combustion reaction of methane, and if they can ask two different thing. How? let me discuss one more question. In combustion process of methane, if we used 128 grams of CH4, how many molecules of CO2 produced? Answer in terms of Na. Answer in terms of Na. See, again for this question we are going to do two separate things. One, larger method, and second one, smarter method. Choice is all yours. One, larger longer method, and second one is a smarter shorter method. Choice is all yours, bacha party. So let we do. First, by normal process, gram to moles, moles to moles stoichiometry, and then mole to molecules. First, combustion reaction of carbon dioxide, methane. So methane in the presence of excess oxygen combine with the methane to produce the CO2 as well as water molecules. Let me balance equation. 4 hydrogens, 2 moles, oxygen will be 2, this side 4, so it becomes 2. Done? Done, sir. Sorted, sir. Sorted, sir. Now, beta, we have the mass of methane. Mass of methane is given in a question and it is 128 grams. And what is molar mass of methane? 12 plus 4, 16 gram per mole. Now, what is moles of methane? It is mass divided by molar mass, beta. Mass is 128, molar mass is 16. 128 divided by 16. 16 divided by 128 divided by 16. 4 4s are 16. 32 4s are 28. 8. 16 8s are 128. So 8 moles. Here we have 8 moles, right? Now, beta, if we have the moles with this reaction, you can say that compare these two. Which one is given and which is asked? Done? I can write that 1 mole of CH4 can produce 1 mole of CO2. Right? Now, 8 moles of CH4 can produce how many mole? So if it's 1:1, then you can say that it's 8:8, sir. So 8 moles of CO2, we have 8 moles, right? Cross product directly done. But in question, there we have been asked to find molecules of CO2, not the mole. Now for molecules. So number of CO2 molecules. What is the formula of molecules from mole? It will be eta or n into Avogadro number. So beta, it becomes 8 into Na. So we have 8 Na molecules. 8 Na molecules. Moles into molecules, right? So we have a 8 Na molecules. It is the longest method. The finally answer comes, but it is a longest method. Sir, now you have a KKC. Yes, my dear student, we have a KKC, not me. We have KKC. Together, you and me can solve this sum in only few lines. What suggests KKC? Right balance chemical reaction. So CH4 plus twice O2, it gives CO2 plus twice H2O. Done, beta? Yes, sir. Now, what is given write only in the stoichiometrical coefficient. Stoichiometry, what is given? So in stoichiometry, we have a CH4 in terms of a mass. So write it mass of CH4 and molecules of CH4. Write like this. On the up hand side, what is given and which way we have to find. Write down that and write of that stoichiometry. From these we can say that 12 plus 4, 16 gram of CH4 can produce 1 mole. So Na molecules of CO2. Now in given question 128 gram. So 128 gram of CH4 can produce how many molecules of CO2? Directly beta. Mass to molecule comparison taken as directly, and yes we can definitely beta. So 128 into Avogadro number divided by 16. 128 into Avogadro number divided by 16. So let me do the calculation. 128 into divided by 16. Already we know the answer. It will be 8. Yes. So 8 Na. 8 Na. Directly we can get the answer. So it is the power of KKC. Your whole numerical considered in only 2 lines, only 2 steps. Done beta. Is it clear? Is it clear? Let me move forward for another this type of sum. Now we only apply direct KKC. Let me do it. Let me do it. In the combustion process of ethane, combustion process of ethane, if we used 224 liter of O2, how many grams of water produced? Simple reaction. First of all, we have to write balanced chemical reaction beta. Balanced chemical reaction, combustion process of ethane, C2H6 plus O2. It gives CO2 plus H2O. I already leave space here before the molecular formula for moles, right beta? So now let me balance. 2 carbon, so here 2 moles. 6 carbon, so here 3 moles. Now for oxygen, 2 2s are 4 plus 3, 7. So here we have to put 7 by 2 because 7 by 2 multiply with 2, it becomes 7. So left hand side and right hand side number of atoms will be same now. Now which we have to compare. We have a volume of O2. So put V sign above it. And we have to find mass of water. So put M sign above here. Right? Now from the stoichiometric. Right, volume of this, it becomes 7 by 2 into 22.4 liter of O2. It can produce, right, mass below this. What is the mass? It becomes 3 into 18 gram of water. Done beta? Now it is given from the stoichiometry. Now what is given in question? So write given exactly below this. So in given, they told about 224 liter of O2 from how many grams of H2O produced. Simple things beta, simple things. Just to make a cross product here. 224 into 3 into 18 divided by 7 by 2 into 22.4. These 2 goes in the numerator. 2 into 2 24 into 3 into 18 divided by 7 into 22.4. 10. Done beta. Now 3 2s are 6. 10 into 6 into 18 divided by 7. Now I am doing this calculation for simplification. You can do it by normal method also. 18 6 are 108 into 10 means 1080 divided by 7, right? So let me do a simple calculation over here and then match our answer with calculator also. So 7 ones are 7, 38, 7 5s are 35, 30, 7 4s are 28, 20, 7 2s are 14, 60, 7 8s are. So it will be approximately 154.28 grams. Now let me check our calculation is whether correct or wrong. Let me check once with calculator, right beta? See, 2 into 224 into 3 into 18 divided by 7 divided by 22.4. So yes, we have the perfect answer, 154.28 grams. So by the smart KKC, you can do simply way solve MCQ perfectly. Done beta. Let me move towards the another one MCQ. In which if 116 gram of butane gets burned in the presence of excess air, how many liters of CO2 produced? We have to write a combustion reaction of butane. Which is butane gas? C4H10 is your butane. Methane, ethane, propane, butane, 4 carbon. C4H10 is your butane. Plus combustion, so addition of O2 and the converted into CO2 plus water. Let first of all balance this chemical reaction. 4 carbon, 10 hydrogen, 5 hydrogen. 5 2s are 10. Now 4 2s are 8, 8 plus 5. 9, 10, 11, 12, 13. So here we have to put 13 by 2. Done. Now we have to do comparison of butane. In which term? Mass of butane is given and finding a volume of CO2. So mass versus volume comparison. Now from the stoichiometry, you can write that molar mass of butane 12 4 48. 48 plus 10, 58. So we can write that 58 gram of butane can produced for 4 into 22.4 liter of CO2 gas at STP. Done beta. So now if we have only 116 gram of butane, then how many liters of CO2 produced? So straight away 116 into 4 into 22.4 divided by 58. So 58 2s are 4 2s are 8. 8 into 22.4. 8 into 22.4. Done beta. So it becomes 169.2 liter. Wait a second, let me check. 8 4s are 32, 2 3, 9, 8, 16 plus 1 70. Sorry, 179. 179.2 liters. right? Volume of CO2 produced, we have 179.2 liters. Yes, answer is this. Done, beta. Clear. Let me move towards the next question. By complete decomposition of 9.85 gram of calcium barium carbonate, how many liters of CO2 gas produced at STP? We have to write a simple equation of barium carbonate. When barium carbonate get decomposed in the presence of heat, we have a barium oxide and carbon dioxide as gas. Done. Now beta, we have to compare mass with liter, right? So mass versus volume. Again, with the help of a stoichiometry, mass of atomic mass of barium is given. So find first of all molar mass of BaCO3. So it will become 137 plus 12 plus 48. Done. 16 threes are 48. So molar mass of BaCO3 becomes 7 plus 1, 5, 6, 7, 8, 9. 197 gram per mole. 197 gram per mole. Right? Now let me compare from stoichiometry. 197 gram of BaCO3, it is a balanced chemical reaction, can produce 22.4 liter of CO2 as STP. So now in question they are given as 9.85 grams of these BaCO3 can produce how many liters of CO2. If they can ask in millimeter, you can do by multiplying it with 1000. Done, beta? So now it becomes 9.85 into 22.4 divided by 197. Most probably 7 5s are 35. 197 5s are 985. So you can cut this and write as 0.05. Right? 2 decimal 0.05. Now beta it becomes 1 by 20. So here it becomes 22.4 divided by 20. By 2 it becomes 11.4 divided by 10. 1.14 liter. 1.14 liter. Okay, divide by 2. So it becomes 11.2 and divide by 10, 1.12 liters. Sorry, 1.12 liters. Yes, option number D is your correct answer. 1.12 liters. Done, beta. By the smart short KKC trick, you can solve these type of MCQ in quick note. Let me move towards the next question. A compound having the empirical formula CH2O and its vapor density is 30. Find the molecular formula. What is the relation between empirical formula and molecular formula? We know the relation. Molecular formula is equals to n number into empirical formula. But sir, from where we can get this n number? It's simple. What is the n number? Number n equals to molar mass divided by empirical formula mass. Empirical formula mass. It's a simple thing. Now beta, molar mass from vapor density we can find it. What is the formula? Vapor density equals to molar mass divided by 2, because molar mass of hydrogen is 2. So vapor density is 30, then 30 into 2 becomes its molar mass. So molar mass becomes 60 gram per mole. And what is empirical formula mass? So empirical formula mass of CH2O. Atomic mass of carbon is 12, hydrogen is 1, so 1 2s are 2 plus 16. So it becomes 30. 30. Done beta? So now by this thing, we have n number, which is molar mass divided by empirical formula mass. Empirical formula mass. So molar mass is 60. Empirical formula mass is 30. So n the number is becomes 2. So now molecular formula beta. Molecular formula becomes n number into empirical formula. So what is n number? 2, and what is empirical formula? CH2O. So twice of CH2O, it becomes C2H4O2. C2H4O2. What is the correct answer? C2H4O2. Option number C is your correct answer. Option number C is your correct answer. Done beta? Okay. Yes sir, clear. Now the next most important concept, and it is about limiting reagent. What is a limiting reagent? A substance that does not allow a chemical reaction to take place completely is called limiting reagent. Simply, limiting reagent means a reagent which limits the productivity of a reaction. Limiting reagent is a reagent. In a simple word, a reagent which is in lesser proportion. Lesser proportion. So its limit the productivity of reaction. Suppose beta, you want to study whole 24 hours, but yes, your sleep cycle of 7 hours will not allow you to study 24 hours completely. Your addiction towards the mobile gaming, which consume your 2, 3, 4, 5 hours, important hours before your NEET examinations. These are limiting reagent, which limits your NEET mark. Understand? When there will be a two reagent, one is 24 hours of time and one is your limiting reagent, addiction towards the mobile gaming. So your mobile gaming restricts your NEET hour studies, NEET study hours. So it is a limiting reagent which restrict you to lesser study, not 24 hour study. I can understand, sir, 24 hour study can't be possible. Yes. Sleep cycle of 7 hours is compulsory, necessary. But out of these remaining hours, how many of your study hours are fruitful? Please do calculation now. Please sincerely do calculation now. Beta, time is money. Time is your money. Right now, your only money is time, beta. If you waste your time in different activity, keep sleep cycle aside. 6 to 7 hours of sleep is compulsory. If you are taking 9 or 10 hours of sleep, it is your indicating your lazy nature. 6 to 7 hours sleep is compulsory, I can understand. But beta, if you sleep more than 7 hours, it is a sign of a lazy nature. So beta, 7 hours sleep, no problem in that case. But out of that remaining hours, 24 minus 7, still you have approximately 18 hours, right? 18 hours or 17 hours. Let me count as a 15 hours. let me take round off 15 hours, 9 hours gone in sleep, eating food and your daily routine. Still you have 14 to 15 hours left. In these 15 hours, how many hours you converted fruitfully in your NEET study? It is the important part. So now again back to the topic. What is limiting reagent? See, if I am writing a simple equation, 1 mole of A reacting with the 1 mole of B to produce 1 mole of C. See, if I have 100 moles of A, 100 moles of A, but I have only 50 moles of B. How many moles of C can be produced? 1 to 1, 1 to 1. So A is in a excess, 50 moles of B, so C will be formed only 50 moles. Only 50 moles. So the production of C will be restricted to the 50 moles because we have 100 moles of A. So we can easily produce 100 mole of C, but we have limited B. So here B is in a lesser proportion. So it is your limiting reagent. And yes, of course you can say that, sir, A is in a excess proportion. Yes, beta, A is in a excess proportion. So here your A is excess reagent. One among the two reagent, one is limiting reagent and one is excess reagent. Sir, please explain these with one more example. Okay, beta, fine. Let me take another example. Wait a second. Let me take another example. Come. Yes. 5 moles of N2 react with 30 moles of H2. How many moles of NH3 formed? And which reagent is limiting reagent and which reagent is excess reagent? See, beta, sir, how can we find limiting reagent? A simple strategy I am going to give you to find limiting reagent. But before that, please make sure 1 kkc. Please write down 1 kkc for LR. 1 kkc for LR. Sir, where we have to apply the concept of LR? For this we have a kkc. For this we have the kkc. The concept of LR and ER is only applicable when in question two reactant is given. Whenever in question two reagent is given, then only the concept of limiting reagent and accessing reagent is applicable. Only in a one condition, where quantity of two reagent is given in a question. then only you have to apply the concept of limiting reagent. Now for calculating this stuff, first of all we have to write down a chemical reaction between nitrogen and hydrogen to produce NH3. Let me balance it first. Let me balance this first. N to 2, so here it comes 2, 2 3s are 6, so here comes 3. Done sir, clear sir. Now for finding limiting reagent, we have to write two things. Generally we apply stoichiometry first and the given second, but for finding a limiting reagent, first write down given things. In a given scenario, we have 5 moles of N2. So given 5 moles of N2 and given hydrogen mole is 30. So firstly write down the given values. Now secondly write down the stoichiometric coefficient of these two. So for here stoichiometric coefficient is 1, for here stoichiometric coefficient is 3. Done beta? Now beta, after writing down the stoichiometric coefficient, let's take a simple ratio. And what is a simple ratio? It is for LR. So next step for LR, next KKC for LR is for limiting reagent. Find ratio of given divided by stoichiometrical coefficient. Given divided by stoichiometrical coefficient. And the conclusion is which one the smallest is LR and which one the largest or the larger one is your ER, is your excess reagent. Let me do it. Okay sir, simple ratio sir, simple thing. Given divided by stoichiometric coefficient, given divided by stoichiometric coefficient, it will become 5 and it will become 10. Which one is the smaller? Sir, 5 is the smaller. Yes beta. Then in that your scenario, your nitrogen will becomes your LR. Your LR and your hydrogen is becomes ER. Done beta. The ratio which is higher is your ER. The ratio which is lower is your LR. Got it sir. Now sir, what about the product? We find LR, ER, but what about the product? See, the KKC is extended here. For product always wait a second, please make a correct statement. Find product with help of LR. We must find product with the help of LR. Limiting reagent. Now, sir, for this question, we have the clear things about these two things, LR and ER. So, first make mention here. Limiting reagent is nitrogen and excess reagent is your hydrogen. Done beta? Now we have to find the product with the help of, please for LR, ER, follow this flow chart. And now for the moles of NH3, we have to compare with LR. So compare N2 with NH3. Compare N2 with NH3. And for finding product, we have to first take a stoichiometric coefficient and then given. But for finding LR, the ratio will be reverse. Given versus stoichiometrical coefficient. Done beta. What is the stoichiometric coefficient of NH3? It is 1 mole. So 1 mole of N2 will produce twice mole of NH3. Twice moles of NH3. Done beta. So now in a given question, how many moles of NH3? It is 5 moles of NH3. So 5 moles of NH3 of N2, sorry, can produce how many moles of NH3? How many moles of NH3? So it becomes beta 5 2s are 10 divided by 1. So 10 moles of ammonia produced. We have excess molecules of hydrogen, excess moles of hydrogen. With its help, we can produce more NH3, but our N2 get finished first. So the reaction will be stopped at that moment when N2 gets consumed. Done beta? So finally, this is your answer. 10 moles of NH3 can be formed. So by this smart trick, you can find LR, limiting reagent, excess reagent agent, by taking simple ratio. First, where the concept of LR ER comes, when the two of the reagent quantity is given, then only the concept of LR ER used. And by finding the LR ER, we can simply find the moles of product with help of a limiting reagent. Done beta? These 4 steps are important. These 4 steps are most important steps. Let me do some 1-2 numerical amongst the LR ER so you get clear idea. You get clear idea. Done beta? Let me do it. Let me do it. In a combustion of methane, if we use 10 moles of methane, 10 moles of methane and 30 moles of O2. How many moles of water? How many moles of water formed? As well as they ask in second question, find which reagent is LR and ER. Which reagent is your limiting reagent and which reagent is your excess reagent? Third question. See, I write 3 questions in 3 different colors. Also find how many moles of LR, ER, sorry, ER becomes unreacted. How many moles of ER remains unreacted? Proper word is remains. Right? 3 questions we have to find. Actually the 4. Product, LR or ER and unreacted moles of a excess reagent. We have to find these 3 quantities. Let me begin to first of all find LR. For LR, we have to write a chemical reaction. So first of all, combustion process of methane, CH4 on reacting with O2 to produce carbon dioxide and water. Let me balance this reaction. 1 carbon, 4 hydrogen, 2 2s are 4. Now oxygen 2 plus 2, 4. So it becomes 2O2. Done, sorted. Now for LR, why we have to find LR? Because both the reagent are given. When the 2 reagent given, concept of LR will be applicable. Now finding the LR, we have to write here first given and then stoichiometric coefficient and then simple ratio, Then simple ratio beta. Ratio, let me start. First thing, 1 mole of given moles of methane 10, given moles of oxygen 30, stoichiometric coefficient of methane 1, stoichiometric coefficient of O2 2. Done. Now ratio 10 by 1, it becomes 10, 30 by 2, it becomes 15. Which one is higher? Which one is higher? Obviously sir, 15 is higher. So which one is lesser? CH4 10 is lesser. So you can straight away write your LR is CH4 and your ER is O2. See, here we get one answer of this blue question. Which one is LR and which one is ER? Now beta, for product we have to use LR. For product, for finding a product, we have to use LR. So for LR, let me write the equation again. Which one is LR? CH4. So comparison of CH4 to the which product we have to find? H2O. So CH4 to the 2H2O. This time we have to write this vice versa. First stoichiometric coefficient. So you can write here, with the help of 1 mole of CH4, we can get 2 moles of water. 2 moles of water. Done beta? So in question we have given as 10 moles of methane. So 10 moles of CH4, how many moles of water can be formed? Moles of water can be formed. So beta, it becomes 10 into 2 divided by 1. So it becomes 20 moles of water. 20 moles of water we get. We get 20 mole of water. Done beta? Now beta, we have the product also. Now the last thing, when we have to find ER, how many moles of ER gets unreacted? So for finding this, we have to comparison LR with ER. LR with ER. LR to ER comparison. So for this, I have to write CH4 as LR and 2O2 as ER. So I am writing it with a stoichiometric coefficient and then given. So I can write that 1 mole of CH4 used 2 moles of O2. 2 moles of O2. So beta, in question 10 moles of CH4 is given. So 10 moles of CH4 used how many? It's 2 mole. How many moles of CO2 beta? So here we find mole of O2 which is used. So used mole of O2 becomes 10 into 2. So it becomes 20 moles. Beta, 20 moles of O2 used. Okay sir, got it. With the 10 mole of CH4, 20 mole of O2 get consumed or used. We have to find unused, remain unused, unreacted moles. So now I can write that moles of O2 which is unreacted becomes moles of O2 given minus moles of O2 used. Given minus used gives you unreacted moles. So moles of O2 which given is 30 moles and moles of O2 which used is 20 moles. So 30 minus 20, it becomes 10. So moles of O2 which is unreacted is 10 moles. Is 10 moles. Clear beta? they are not asking you that much question, they can ask any of these three question, any single question of these three question. It is the most important sum. Please make it KKC. It is the most important sum. Please make it as KKC. Please make it as KKC. Clear, beta? Clear? Now let me move towards the another thing. Question MCQ. MCQ. Let me solve it. Y mole of N2 is reacting with the 10 moles of hydrogen. How many moles of NH3 produce? See, two types of reactant is given. So first of all, write the balanced chemical equation. N2 plus 3H2, it gives twice NH3. Right, beta? Now for first of all, for product we have to find LR. We can't find product directly. For product we have to identify which one is LR among these two. So for LR, first of all, we have to write given versus stoichiometrical coefficient and then taking a simple ratio. Let me do it. Given mole of N2 is 5. Given mole of H2 is 10. Stoichiometric coefficient is 1 and 3. Now the ratio becomes 5 versus 1. 10 versus 3, so it becomes 5 and this becomes 3.33. Which one is the smaller one? So you can write the way H2 is LR. So now you have to find product with the help of H2. With the help of H2, from 3 mole of H2, we have 2 moles of NH3. So now for this purpose, first of all you have to write stoichiometric coefficient, then you have to write given to find. Done? Now stoichiometrical coefficient 3 mole of H2 gives 2 moles NH3. Now in question we have 10 moles of H2. How many moles of NH3 find? State away beta. 10 twos are by 3. It becomes 20 by 3. 6 threes are 18, 2 again 26.67. 6.66, approximately 67 also, or 6.66 moles. So do we have the answer? Yes. Your option C is the correct answer. Clear, beta? So by this smart trick, you can solve this type of MCQ in few seconds. Let me move to the another MCQ. If 5 moles of CH4 is burned in the presence of 12 mole, we will get CO2 and H2O. Which of the following reagent is a limiting reagent? Simple question. Let me write down the balanced chemical equation. CH4 plus 2O2, it gives CO2 plus twice H2O. I write down already balanced chemical reaction here. Now for limiting reagent, we have to mention stoichiometric coefficient, given versus stoichiometrical coefficient. So first of all given, then stoichiometrical coefficient, and then the ratio comes, simple ratio comes. Okay? Okay, fine. First of all given moles, 5 mole versus 12 moles, stoichiometrical coefficient 1:2, 5 by 1, 12 by 2. It becomes 5, it becomes 6. Which one is the smaller one? 5. So you can write down there CH4 is LR, limiting reagent. Yes, CH4 is your limiting reagent. Done, beta? So this type of stoichiometric question or limiting reagent question can be asked. Now let me move to the another important topic. It is also the heart of this chapter as well as solutions chapter. Concentration terms. Now basically beta, in class 12 when you study the chapter solutions, you can also learn about the things concentration terms. But beta, first of all, what is concentration terms? what is concentration and what is concentration terms. Basically beta, concentration is a simple ratio. Concentration is a simple ratio of quantity of solute to the quantity of solution. Sir, quantity of solute. What is solute? See beta, your solutions have the two component. Your solutions have two types of component. One is solvent. See, solvent is a 1, 2, 3, 4, 5, 6, 7. 7 letters word. Whether solute is a 6 letters of word. So, in solution which is present in a lesser quantity, lesser amount is your solute, where the maximum quantity is your solvent, because solvent is a 7 letter word, solute is a 6 letter word. So it's a simple to remember beta. In solution, if I made a one lemonade, with the help of glass of water, I pour 2 spoon of sugar, little small spoon of salt and 1 whole lemon. My lemonades get ready. In this lemonade, the water is in maximum proportion, so it becomes your solvent, and the other 3 things, sugar, salt and lemon, which is in a lesser quantity, lesser amount, is become your solute. Clear? What is solute? What is solvent? Now, quantity of solute upon quantity of solution is becomes your concentration. And for concentration terms, we have to study different concentration terms. 5 types of different concentration quantity. First is percentage. In this percentage segment, we are going to study percentage W by W, weight by weight, or mass by mass. In chemistry, weight or mass is same. In chemistry, weight and mass will be considered as the same. In physics, you consider both the things differently, but in chemistry, they are same. Percentage of W by V, percentage of V by V, volume by volume, mass by volume. Second terms which we are going to study is ppm, parts per million. In parts per million, we are going to study ppm in W by W, weight by weight, ppm in mass by volume by volume, and last thing ppm in weight by volume. Then we are going to study about 1 mole quantity concentration term, which is your mole fraction, which is denoted by chi. Then we are going to study about 2 simple volumetric terms, molarity and normality. And the last concentration terms is based on the mass, which is molality. So beta, molarity denoted by capital M, molality denoted by small m, and normality denoted by capital N. Today in this session, we are going to see all the concentration terms. Done beta? Please once see these all the concentration terms, then we are going to start this. Done beta? So today, yes, we are going to see all these formula and their numerical. Let we begin with the first thing, percentage versus ppm. It's a interesting thing. Both the formula is quite similar. Wait a second, both the formula is quite similar beta. Done? And let me understand it. What is percentage? Whenever we talk about the percentage, we consider it to the 100. So it is 10 to the power of 2. And when we consider parts per million, then it is 10 to the power 6. Remember, we already learned that parts per million is 10 to the power 6. billion is 10 to the power 9 and trillion is 10 to the power of 12. Done. So now percentage versus ppm. Percentage versus ppm. Yes, beta. Left hand side we are going to take percentage and on right hand side we are going to take parts per million. See, we have a three different formula for percentage. First is percentage W by W. It is called weight by weight or mass by mass. What is its formula? Percentage W by W is mass of solute upon mass of solution, which is solute plus solvent, right? Mass of solute upon mass of solution into 100. Now simultaneously, if these W by W taken in ppm, then W by W in ppm, the formula is same, mass of solute upon mass of solution, but instead of these 100 we are going to take 10 to the power 6 here. Beta, basically what is parts per million? Per million molecules of a solution, how many molecules of solute exist? It is called parts per million, right beta? Now same formula of V by V, percentage volume by volume. It means volume of solute upon volume of solution into 100. Now in this segment, ppm in V by V or V by V in ppm, right? Then the formula remains the same, volume of solute upon volume of solution into 10 to the power 6. Now the same formula W by V, same type of formula W by V, it is the third one, right? Yes. Now fifth one, percentage weight by volume. It means mass of solute, basically it is type of density upon volume of solution into 100. And here in this segment, ppm in W by V, it is mass of solute upon volume of solution into 10 to the power 6. Clear beta? See, these two quantity is unitless because it's mass by mass or volume by volume, but these quantity have a unit which is mostly gram per ml or yes, gram per ml into 10 to the power 6 and here into 10 to the power 2. Done beta? Gram per ml. Yes. Done. So these are your formulas for percentage and ppm. But sir, which type of question or which data can we obtain from these formula? Let me discuss again. Percentage versus ppm. Which type of data can be derived? If they said 10% W by W, what it means? It means beta 10 gram of solute in 100 gram of solution. In 100 gram of solution. See beta, remember the formula? Put here 10 by 100. 10 by 100 it becomes 100 get cut. So 10% W by W. It means 10 gram of solute in 100 gram of solution. Now with these two data, we can find mass of solvent. Mass of solvent becomes mass of solution minus mass of solute, because solute plus solvent becomes solution. So mass of solution is 100, 100 minus 10, it becomes 90 gram. It becomes 90 grams. Clear beta? Now beta, 10 percentage if they given as 10% V by V. What it means? It means that 10 ml of solute, 10 ml of solute in 100 ml of solution. So sir, by these we can also find volume of solvent. Yes beta, it is same, volume of solution minus volume of solute. Beta, remember, these are the key concept for numericals. So it is most important thing. So for these 100 ml minus 10 ml, so it becomes 90 ml. Done beta? And if they give you 10 percentage W by V, what it means? It means that 10 gram of solute in 100 ml, sorry, not 1000, 100 ml of solution. Beta, see, these two units are different, ml and gram. So here we can't predict about solvent. Done beta? But now let me discuss. If these three formulas are given in ppm, then what can we do? If they suggest 10 to the power or 10 ppm W by W, 10 ppm W by W, what it means beta? What it means? Same thing, 10 gram of solute, but in 10 to the power, instead of 100, here we are considering 10 to the power 6 gram of solution. See beta, 10 to the power 6 gram of solution. Now beta, in that scenario, if you are talking about mass of solvent, it becomes mass of solution minus mass of solute, right beta? But remember, 10 to the power 6, which is approximately 10 lakhs. From 10 lakhs, if you subtract 10, it is almost equals to 10 lakhs, because it will become 9,99,990, which is almost equals to 10 to the power 6. So for this scenario, remember, for ppm, mass of solvent considered as mass of solution. Almost similar beta. Done beta? It is a key concept. Similarly, when we talk about 10 ppm V by V, if these both are same, you can tell here same. It means 10 ml of solute dissolved in 10 to the power 6 ml of solution. Done beta? So dissolving 10 to the power 6 ml of solution. Now beta, here in this scenario also you can say that volume of solvent equals to volume of solutions. Both the becomes same, almost similar, when they are in a same quantity. But in W by V, we can't judge about solvent quantity, right? So for W by V, you can only say that 10 gram of solute in in 10 to the power 6 ml of solvent. That's it. That's it. Done, beta. I hope it gets clear now. I hope it gets clear now. Let me move to the some numerical. Again, percentage versus ppm numerical. Right? See, first question number 1. Concentration of NaOH in water is 30% W by W. Find this concentration in ppm in W by W form. See, we have a W by W in percentage and we have to find ppm in W by W. Let me begin. First of all, percentage W by W, it means mass of solute upon mass of solution into 100. Right, beta? If here we are taking as 30% W by W, then mass of solute divided by mass of solution into 100. So beta, from these we have data mass of solute upon mass of solution. It becomes 30 divided by 100. So it becomes 0.3. Now beta, we have to find percentage. What we have to find? Percentage. So beta, percentage ppm. Yes, ppm in W by W. It becomes mass of solute upon mass of solution into 10 to the power 6. Now beta, we have mass of solute upon mass of solution as a 0.3 value. So 0.3 into 10 to the power 6. In scientific notation, it will become 3.0 into 10 to the power 5. So it is your ppm in W by W. ppm in W by W. Done, beta. You can solve these type of sum smoothly. Now let's move to the next concentration term, which is your mole fraction. Now what is a mole fraction? Mole fraction can be found for any one of the substance, either solute or solvent. First statement, mole fraction can be found for solute or solvent, for both of them. Now, what is a mole fraction? It is denoted by chi. Later on, it converted to the x. So, what is the formula of mole fraction? Beta, mole fraction is moles of component, any of the component, whether it is solute or solvent, moles of component upon total mole. Moles of component upon total mole, it is called as a mole fraction. So beta, moles upon moles, so it is basically unitless quantity. It is basically unitless quantity. And sir, what is this mole total? Beta, your total mole is N total is equals to moles of solute, each solute plus moles of solvent, moles of solvent. Done beta. Suppose we are talking about mole fraction of a solvent, mole fraction of a solvent, then it becomes moles of solvent upon total mole, which is solute plus solvent. And if you talk about mole fraction of solute, it becomes moles of solute upon total mole, upon total mole. Done beta. So mole fraction can be found for both of them, solute as well as solvent molecule. And let me derive one of the most important formula for mole fraction. Suppose I am considering solvent as a, solvent as a, it is a binary solution, one solvent plus one solute, right? Solvent as a and solute as a b. So there is only two component present. So if there will be two component, the solution is known as binary solution, binary solution, right? So for this binary solution, if we categorize solvent as a, solute as a b, then what will be the mole fraction of solvent? Mole fraction of solvent becomes mole of A upon N total, and mole fraction of B becomes mole of B upon N total. But sir, what is this N total? Beta, total mole equals to mole of A plus mole of B. Done beta. So now you can write that your Chi A becomes mole of A upon moles of A plus moles of B, and simultaneously your Chi B becomes mole of B divided by mole of A by mole of B plus mole of B. Now remember one thing, what will be the value of Chi A plus Chi B? What will be the value of Chi A plus Chi B? Equals to 1. How sir? How sir? In solution always addition of mole fraction of all component will be 1. How sir? See here, let me derive the equation. Chi A is a mole of A upon mole of A plus mole of B. Chi B is a mole of B upon moles of A plus moles of B. Let me take moles of A plus moles of B as a common part of element. So taking LCM, so on the upper hand side it becomes Na plus Nb, so it becomes 1. So it becomes 1. Done beta. So Chi A plus Chi B equals to 1. So here comes the golden one KKC line. The golden one KKC line. In a solution, addition of mole fraction of all components will be 1. Will be 1. Always there will be one answer. Done beta. So it is a simple things that we can learn from the mole fraction. Let me now understand a new quantity. New quantity. Before we went to move new quantity, let me solve one MCQ. One MCQ of a mole fraction. Right? Let me start. If 400 gram of NaOH dissolved in 360 grams of water, find mole fraction of NaOH and water. See, this type of question can be asked. First of all, we have a two data, mass of NaOH, which is given as 40 grams. What is molar mass of NaOH, beta? Molar mass of NaOH becomes 400 gram given, right? And yes, beta, the molar mass of NaOH is a 40 gram per mole. Sodium's atomic mass 23, oxygen 16, hydrogen 1. 23 plus 16 plus 1, it becomes 40 gram per mole. So by these two data, we can easily find moles of NaOH, and it becomes 400 divided by 40. So it becomes 10 moles, right? For water also we can find its mole. For water given mass is 360 gram. And what is molar mass of water? 2 ones are 2 plus 16, 18 gram per mole. So now moles of water becomes 360 divided by 18. So it becomes 20 moles. Done, beta? Now what will be your total moles? Your mole total becomes moles of NaOH plus water. Moles of NaOH will be 10 and moles of water will be 20. So it becomes 30 moles. Now beta, if it is a 30 moles, then now N total will be your 30 moles, then mole fraction of, first of all let me do mole fraction of NaOH. It is moles of NaOH divided by total mole. Mole fraction of NaOH is, moles of NaOH is 10 divided by 30. It becomes 1 by 3. Okay, and now mole fraction of water, it becomes moles of water divided by total mole, beta. Moles of water will be 20 divided by total mole 30. It becomes 2 by 3. Now let's see magic here. 1 by 3 plus 2 by 3, it becomes 1. So total mole fraction, addition of mole fraction of each component is always equals to 1. Done, beta? Clear? Now let me move towards the new physical quantity, new concentration terms. It is your molarity. Which term is this? It is your molarity terms. Now what is molarity? Molarity is denoted by capital M. And what is its formula? Molarity have a simple formula. Molarity, it becomes moles of solute upon volume of solution. Many of students made mistake here. They forgot the unit of volume. Make sure the chances of getting wrong will be higher here. Make sure unit of volume must be in a liter in molarity term. So please do a finger on a right place. So that is a key point to remember. Done, beta? Volume of solution must be taken in a liter unit. Right, beta? Now what is the formula of mole? Mole can be denoted by mass of solute upon molar mass of solute. So another formula of molarity is mass of solute upon molar mass of solute into volume of solution in liter. In liter you have to remember. Done beta? Sir, what is the unit of molarity? Sir, what is the unit of molarity? See, unit of molarity. Unit of molarity is mole per liter. Moles per liter. Moles liter inverse. Moles per liter. Clear? Okay, sir, we have the clear idea about. But sir, what is a 1 molar solution means? What is a 1 molar? It is read as like this, 1 molar solution. What is it means, sir? Beta, 1 molar solution is, it means that 1 mole of solute, 1 mole of solute dissolved to prepare 1 liter of solution. See, 1 mole in 1 liter. 1 molar, 1 gets cut, 1 molar. Sir, then what is the meaning of x molar? In case instead of 1, they ask as a x molar solution. What it means, sir? It means, beta, it means instead of these 1, you can write x mole. Yes, but remember one thing, volume always becomes 1 liter. Volume always taken as 1 liter. So, x mole of solute dissolved to prepare 1 liter of solution. Done beta? X molar means x mole of solute dissolved to prepare 1 liter of solution. Let me do one numerical of molarity. 80 gram of NaOH dissolved in 10 liter of water. Find its molarity. Simple. First of all, we have mass of NaOH. It is 80 and we know the molar mass of NaOH. Molar mass of sodium hydroxide, sodium 23, oxygen 16, hydrogen 1, 40 gram per mole. Right beta? Now volume of solution is also given. Volume of solution which is given is 10 liter. For molarity we have to find first mole of solute. So beta, for mole of solute which is your NaOH becomes mass upon molar mass. What is mass of solute? It's 80 gram divided by 40. So it becomes 2 moles. 2 moles. Done beta? Now beta we have the moles. Now let me apply the formula of molarity. So molarity becomes moles of solute which is your NaOH upon volume of solution in liter. Don't forget in liter. Here it is given in liter. But if it is given in ml, milliliter, then you have to convert that ml into liter. So that beta, your molarity becomes moles of solute. See, what is the moles of solute? We find here 2 moles. And what is the volume of solution? 10 liter. So beta, your molarity becomes 0.2 molar. 0.2 molar. Done beta, clear? Yes, by this simple trick we can find molarity. Now beta, another important term. Let me study another important term. Molarity for dilution. What it becomes molarity? What part should change? What is dilution? If I drinking a lemonade and I found that the quantity of salt is doubled by mistakenly and quantity of lemon is also doubled, then that type of lemonade I can't drink. So for these lemonade I have to dilute it. So what is dilution? So for dilution it means addition of solvent. Addition of solvent to reduce its concentration, right? To reduce the salty or the sour taste, we have to add water in this. It is called dilution. So for dilution we have to add solvent. But beta, whenever we add solvent, remember the key fact: moles of solute remain unchanged. Moles of solute remain unchanged. Remain unchanged. So beta, you can write that moles of solute before dilution is equals to moles of solute after dilution. Because beta, we can't change solute, their quantity, their moles remains the same, right beta? So moles of solute before dilution is equals to moles of solute after dilution. So beta, we can say that what is the formula of moles before dilution, after dilution? See, from molarity we all know that moles upon volume in liter, right? So from this formula your moles becomes molarity into volume. Molarity into volume. Yes, so before dilution, suppose the molarity is M1 and the volume is V1, then M1 V1 equals to M2 V2. M2 V2 is molarity of 2 after dilution and volume of 2 after dilution. Done beta? Now beta, another important part. For mixture of same solution with different concentration, if we mix a same solution with a different concentration, then what happen? Beta, please make this formula as a box. It is most important part. Now let me understand for mixture of a same solution with different concentration. Suppose here I have a one beaker having a volume 5 liter and molarity 3 molar. I have another beaker having a volume of 5 liter, but this time molarity is 8 molar. If I mix these two, we get how much volume? Volume equals to simple V1 plus V2. So it becomes 5 plus 5, 10 liters. But what about the molarity? What about the molarity? For this, we have the formula here. M1 V1 plus M2 V2, it becomes MV. Whether your V becomes V1 plus V2. Yes beta, we have the formula for addition of two different concentration, same solution. Done. So let me put here the values. See, your M1 is a 3 molar, your volume is a V1 is 5 liter, plus your M2 will be 8 molar, your V2 will be 5 liters, your molarity you have to find and volume becomes 10 liters, right? So beta 5 3s are 15 plus 8 5s are equals to 10 into M. So 40 plus 15, 55 divided by 10 is your new molarity. So beta, your new molarity will be 5.5 molar. 5.5 molar. Done beta? Clear? So these two formula is important. One is for dilution and the another one is for addition of two different components. Done. It is your molarity. Now let me move towards the new concentration term, molality. Beta, actually it is denoted by the small m. Molality. There is a difference between molarity and molality. Molarity denoted by capital M, but the term molality denoted by a small m. And what is the formula of molality? In the both case, mole will be the same. So on the upper side, it will be moles of solute. But here from the denominator segment, in molarity we use volume of solution, but in molality we are going to use mass of solvent in kg. Remember, in molarity volume of solution in liter, here mass of solvent in kg unit. Done, beta. Now see what is the unit of molality. What is unit of molality? Molality's unit is moles, which unit is mole per kg. Mole per kg. Done, beta. Now let me understand what is the definition of 1 molal. What is the definition of 1 small m? It is read as 1 molal. See, molarity we have capital M. For molality we have small m. Now beta, what is definition of 1 molal? It means 1 mole of solute dissolved in 1 kg of solvent. 1 kg of 1 moles of solute dissolved in 1 kg of solvent. Done, beta. And sir, instead of 1 molal, if there will be given as x molal, then it is read as x molal. And what is the meaning of this x molal? It means that x mole of solute dissolved in 1 kg of solvent. 1 kg of solvent. Done, beta. Remember, the denominator will be always 1 kg. Whether the mole can be changed. Done, beta. Yes. Next important KKC point. In molality, KKC, please mention it. In molality, we are using mass term. So it is independent from temperature. Beta, we all know that if temperature change, volume will be changed, but no mass will be changed. So molality is basically independent. From temperature. Let me move towards the next question. Find molality of aqueous 10% W by W NaOH solution. If not given, take this as a aqueous, right? See, first of all, what we get from the 10% W by W? We know that I already write this statement of 10% W by W. It means 10 gram of solute. Which is your solute in this scenario? NaOH is our solute. 10 gram of solute in 100 gram of solution. So by this we can also find mass of solvent. Mass of solvent will be mass of solution minus mass of solute. Mass of solution is 100 gram. Mass of solute is 10 gram. So it becomes 90 gram. It becomes 90 gram of solvent. Now beta, let me turn this solvent into kg. Mass of solvent in kg, it becomes 90 divided by 1000. 90 divided by 1000. So 0.09. 0.09 kg. Now beta, we have to find molality. For that we have to find moles of NaOH. So first of all, mass of NaOH is given 10 gram. What is molar mass of NaOH? Molar mass of NaOH is a 40 gram per mole. 40 gram per mole. Done. Now beta, remember, moles of NaOH. Moles of NaOH, it becomes mass upon molar mass. Mass upon molar mass. So it becomes 0.25 moles. So it becomes 0.25 moles. Now beta, we have to find molality. So formula of molality is moles of solute upon mass of solvent in kg. In kg. So beta, moles of solute is 0.25 and mass of solvent is 0.09. So straight away it becomes 25 divided by 9. So straight away it becomes 25 divided by 9. 9 2s are 18. Let me do calculation here. 9 2s are 18. 70. 9 7s are. So approximately value comes is 2.70. 2.7. 2.7. Approximately you can take it. Further you can do more calculation, but approximately it will become 2.7. Done beta? So your molality comes 2.7, 2.8. Nearby answer you can find from option. Next concept. It is most important concept. It is about normality. What is normality? See, it is quite similar to molarity, but there is some different. What is molarity beta? Molarity is mass of solute. If I expand mole, it becomes mass of solute upon molar mass of solute into volume of solution in liter, right? We all remember this formula. But beta, what is normality? First of all, it is denoted by capital N, normality. Formula of normality is quite similar. Mass of solute as it is, in denominator volume of solution in liter as it is. But instead of molar mass, here we are taking equivalent mass. What's up? Equivalent mass. Equivalent mass of solute. Okay, sir. Sir, but what is equivalent mass? Yes, you have question in mind. Sir, what is equivalent mass? So remember, equivalent mass have a different formula. Equivalent mass is molar mass divided by n factor. N factor. Molar mass divided by n factor. Again one more question arise in your mind. Sir, now what is this n factor? So first of all, we don't understand normality because normality connect equivalent mass. But sir, now what is equivalent mass? It connect n factor. We know molar mass, sir. But sir, what is n factor? Beta, n factor can be found differently for different type of solutions. N factor can be found differently for different kind of a solute or solution. Sir, then what is n factor? See beta, we can find n factor by 5 different methods. 4 different methods, sorry. N factor by 4 different methods. First, n factor for acids. For acids will be different. Will be totally different. For base, oh my god. For base it is also different. For salt it is also different thing. For salt it is also different thing. And for redox it is also different thing. So for these 4 different type, we can find n factor differently. For acids, n factor count as basicity. Sir, what is basicity? Please wait for some time. Please wait for some time. You get all clear idea about all these 4 things. What for base, it's acidity. For salt, it is charge. And for redox, it is change in oxidation number. Change in oxidation number. Oh sir, it is very difficult thing normality. No beta, it isn't. If you study these 4 things properly, then it is too much easy. Too much easy. Let me begin. Let me begin n factor. Right? For equivalent mass, let me begin with the n factor. But first of all, what is equivalent mass beta? Equivalent mass is molar mass divided by n factor. Now let me discuss n factor. Let me discuss n factor. So, first thing, n factor for acid. N factors for acids. For acid, n factor is its basicity. For acid, n factor means basicity. But sir, what is this basicity? Beta, basicity is nothing but number of H plus released by acid on ionization. On ionization. Whenever we dissolve acid, ionization happens, and at the time of the ionization, number of H plus released by any acid is called is basicity. Okay sir, we got little bit idea about it. Little bit idea about it. Let me find for some acid. Let me find it for some acid. For example, for HCl, whenever we dissolve HCl in water, it produced on ionization H plus plus Cl minus. So number of H plus released by HCl is your n factor. So for this scenario, your n factor will be 1. Will be 1. Same thing for H2SO4. For H2SO4 beta. For H2SO4, whenever we dissolve H2SO4 in water, H2SO4 in water, it produces 2H plus SO4 minus 2. So for this case, your N factor will be 2. Your N factor will be 2. Let me study some of the phosphorus oxo acid here, because its N factor is most important thing. For H3PO4, the N factor will be 3. For H3PO3, the N factor will be 2. And for H3PO2, the N factor reduced to 1. Why sir? Let me discuss. Let me have to check their structure here. Based on the structure, this N factor gets changed. Let me draw the first structure of H3PO4. Remember, phosphorus is at center, connected with the doubly bonded O, then OH, then 3 OH bond. These OH bond are polar. Thus, these can be break down easily and produce all 3 hydrogen. So whenever these first bond break down, we got first hydrogen, this one. If you break this bond, we get second H plus. If we break this bond, we get 3H plus. So in this scenario, we get 3H plus by breaking the bond. So its N factor will be 3. But beta, for second structure, which is your H3PO3. Remember, second structure is H3PO3. Its structure is like this. P doubly bonded with O, another one OH, and the last one is only H, which connected directly to the P. So there is no electronegativity difference between P and H. So if you break this bond, not H plus will be formed. It is formed as a H free radical. So beta, in this scenario, only 2 hydrogen is polar. Which get released. So beta, for these your N factor will be 2. Clear beta? So here in this case, your N factor will be 2. And let me study the last case. The third one, which is your H3PO2. In the case of these H3PO2, let me draw its structure, where phosphorus is directly connected to oxygen, 1 OH bond and 2 H bond connected directly. Now again, in this scenario, only 1 H plus can released as H plus. Another 2 O are non-polar. So beta, N factor of these is only 1. Now you get clear idea why the N factor of different acid will be different. You have to remember these 5 N factor commonly for acids. Clear? For acid, N factor is equals to number of basicity. Basicity is equals to number of H plus get released when ionization. Done? Let me move towards the another equivalent mass, another term equivalent mass. This time it is for base. So now the secondary terms. Now let me introduce the second N factor for base. N factor for base. Beta, for base, N factor, we know that N factor is acidity. N factor is acidity. But now the again new question arises. Sir, what is acidity? Simply beta, acidity is number of OH minus ions released on ionization. On ionization. On ionization, number of OH minus that gets released. It is your basicity. It is your basicity. Let me study. Let me take first example simply. NaOH. On ionization, on reaction with water, it produces Na plus plus OH minus. So number of OH minus is 1. So N factor becomes 1. Here. Let me take another example, which is your BaOH twice. On ionization, it produces Ba plus 2 ion plus twice OH minus ion. So N factor of these, will be considered as a 2. Let me take another example. AlOH thrice. With reaction with water, it produces Al plus 3 aqueous plus 3 OH minus aqueous. So beta, N factor becomes 3. Done beta. It is a simple thing. N factor for base. Now beta, what is N factor for salt? Let me discuss. What is N factor for salt? N factor for salt. Yes, we know that N factor for salt is charge. N factor for salt is charge. Sir, charge on cation or anion? Anyone. Salt created by the two equivalent charge. So whether you consider cation or anion, it will be almost same. Charge. Let me take one example. For MgCl2, we know that it formed by Mg plus 2 Cl minus. So it have positive 2 charge and negative 2 charge. So N factor will be always positive. So N factor will be 2. Done beta? N factor will be 2. Next example, AlCl3. It becomes Al plus 3 Cl minus. So beta, your N factor becomes 3. N factor becomes 3. Done beta? So for base, N factor is acidity, which is number of OH minus. For salt, N factor becomes charge, which either charge on cation or anion. But now for redox reaction, what is N factor? Third thing, what is N factor for redox reaction? Either reduction or oxidation, right? The fourth one, N factor for redox. See beta, for N factor for redox reaction is change in a oxidation number, either increasing or decreasing. We only consider the change in oxidation number. Change in oxidation number is considered as N factor for the redox reaction. Now let me understand. Let me take one common reaction. MnO4 minus in acidic medium, it turns into Mn plus 2. See, here the oxidation number change. Here let focus the oxidation number change from plus 7. Oxidation number of O is considered as a minus 2, 4 2s are minus 8, minus 8 go on the right hand side, minus 8 becomes plus 8, plus 8 minus 1 becomes plus 7. So plus 7 to plus 2 beta. So change in the oxidation number is your N factor and it is decreased by 5. So your N factor becomes 5. Your N factor becomes 5. In a light basic or neutral medium, MnO4 minus in a neutral medium, it becomes MnO2. So here the change in the oxidation number is from plus 7 to plus 4. Plus 7 to plus 4. So it is decreased by 3. It is decreased by 3. So beta, your N factor becomes 3. Clear beta? So in each scenario, equivalent mass of MnO4 minus will be different. If you find equivalent mass in this basic medium, equivalent mass in neutral medium of MnO4 minus in neutral medium, it becomes molar mass of MnO4 minus divided by 3. If you find in acidic medium, then it becomes molar mass divided by N factor, which is your 5. Clear beta? I hope it gets clear. Let me do some numerical to giving you a concept clarity. Let me start. If 49 gram of H2SO4 dissolved to prepare 1000 ml of solution, find normality of it. We have to find its normality. First of all, we have mass of H2SO4, which is 49 grams. Then we have molar mass of H2SO4, which is we have to count 2 into hydrogen 2 plus sulfur 32 plus 4 into oxygen 16. 16 4s are 64 plus 32 plus 2. It becomes 98 gram per mole. Right beta? Now volume is given in ml. Volume of solution is 1000 ml. We have to convert in liter. 1000 divided by 1000, 1 liter. Done beta? Now beta, for normality we have to find N factor. And for H2SO4, we know that it releases 2H plus. For H2SO4 on ionization, it releases 2H plus plus SO4 minus 2. So that N factor becomes 2. So that what is that equivalent mass? Equivalent mass of sulfuric acid becomes molar mass divided by N factor. So it becomes 98 divided by 2, 49 equivalent. Done beta? Now we have a equivalent mass also. Now let me find its normality. What is the formula of normality? Mass of solute upon equivalent mass of solute into volume of solution in liter. Let me put all the data here. Mass of H2SO4 given as 49. Equivalent mass just we derive 49. Volume of solution given as 1 liter. So it becomes 1 normal. So it becomes 1 normal. Clear beta? By these simple formulas you can also find the normality. Now the important things come. Relation between normality and molarity. It is simplest thing. First of all, you know the both the formula. What is molarity? It means mass of solute. Instead of mole, we write mass of solute upon molar mass of solute into volume of solution in liter. Right beta? Now beta, what is your normality? Your normality is mass of solute instead of molar mass. Here we write equivalent mass of solute into volume of solution in liter. But beta, do you remember what is equivalent mass? Yes sir, we have the idea. Equivalent mass is nothing but the molar mass of solute upon n factor. Upon n factor. So beta, can I put this equation number 2's formula in equation number 1? Putting the value of 2 in 1. See, instead of this equivalent mass, I can write that molar mass of solute upon n factor. So, for normality, mass of solute as it is beta, divided by volume of solution in liter as it is, but instead of equivalent mass, I am writing molar mass of solute divided by n factor. N factor. And yes beta, denominators comes to the numerator, so that your normality becomes n factor into mass of solute upon molar mass of solute into volume of solution in liter. See, I separated n factor from this formula because we know that it is the formula of molarity. Yes sir, it is the formula of molarity. So beta, your normality becomes molarity into n factor, or else you can remember the shortcut. Molarity equals to capital N upon small n, which is your n factor. Clear? It is the simplest relation between molarity and normality. Yes, relation between molarity and normality. Again, let we do one simple question. Find normality of 10 molar H2SO4 solution. Find normality of 10 molar H2SO4 solution. So what is the formula? Molarity is equals to normality divided by n factor. So beta, here we have to find normality. So normality equals to molarity into n factor. So beta, what is molarity given as 10 into n factor? Remember, for H2SO4, n factor is 2. N factor is 2 beta. So 10 into 2, it becomes 20 normal. 20 normal. Done beta. It becomes 20 normal. Now let we know. Oh, same question comes. Let it related. All the concentration terms formula we learn all the concentration terms formula we learn today. Which are the concentration formula we learn today? Let me write down. First of all, we learn percentage W by W. Secondary, we learn percentage W by V. Third, we learn percentage V by V. Fourth, we learn ppm W by W. Fifth, we learn ppm W by V. Or sixth, we learn ppm V by V. Then we learn about mole fraction. Mole fraction. Then we learn about 7, 8. Then we learn mole fractions followed by molarity. Then we learn about normality. Then we learn about molality. These all formula we learn. These all 10 formula we learn. Right, beta? And beta, from these formula, I mentioned some of the formula with the star that only contain mass. That only contain mass. These are the formula that only contain mass. These terms only contains mass. So, with the change in temperature, these terms remains constant, because mass do not depend on temperature. Mass do not depend on temperature. So these all terms remain constant with change in temperature, and the rest of the terms, volume, connected with the volume, and if we change temperature, volume gets changed. So the other formula contain volume, and it gets changed with change in temperature. So that formulas are temperature dependent formula. Done. So the remaining formulas are temperature dependent. And which are not temperature dependent? The mass formula, which only contains the mass. Right? Instead of along with these all formulas, I am going to give you some of the shortcut formulas, other important shortcut formulas, which is also the most important for solving the MCQs. So please remember these formulas and denote these with KKC and denote these with KKC. See, other important formula. First is relation between molality and molarity. Relation between capital M and small m. Molarity and molality. What is the formula? 1 by molality. 1 by molality is equals to density by molarity minus density by molarity minus molar mass divided by 1000. Molar mass divided by 1000. Yes, each term denoted it. Small m is your molality. capital M is your molarity. You can direct convert molarity to molality and molarity to molality with use of density. Density is given in question. It must be in a gram per ml, right beta? And small m dash is, capital M dash is molar mass of solute. Molar mass of solute. Yes, you have to remember this formula for getting an answer in minutes. In minutes. Done? We have another formula which is also important, which is percentage of W by W with molarity. Relation of percentage W by W with molarity. With molarity. What is the relation? See the formula. Molarity is percentage of W by W into density into 10 divided by molar mass of solute. Molar mass of solute. See, capital M is molarity. Percentage W by W, which is called as mass percentage. Done. D is your density. And capital M dash is molar mass of solute. Molar mass of solute. Done beta? So it is yet another but important formula. Now beta, let me discuss about acid base neutralization. If we mix the acid and base, then what happens? Obviously a neutralization process happens, sir. We know that, sir, acid plus base, it produced salt plus water. And this reaction is known as, sir, neutralization reaction. Sir, do we have any specific formula for this? Yes, beta, we have. Suppose I have 1 bucket of acid plus 1 beaker of base. And if we mix them, we find the resultant one, right? The result, which may be, if acid is in more concentration, it is acidic. If base in more proportion, it is basic. But what it should be? Then suppose if we have volume of this bucket is V1, normality of this acid is N1. If we have volume of this bucket V2, normality of this beaker N2, then our resultant V will be V1 plus V2. But what about the normality? What is about the normality? Do we have formula? Yes, my son, we have. Normality and volume on the neutralization, it becomes N1 V1 minus N2 V2, or else NV equals to N2 V2 minus N1 V1. Sir, what is the correct one? What is correct one? My dear, both are the correct one. But you have to check the condition. Which condition, sir? If N1 V1 is larger than N2 V2, then you have to apply this formula. And if N2 V2 is greater than N1 V1, then you have to apply the second one formula. Both are correct. Both are correct. But you have to check this. Sir, can we convert this normality to molarity? Yes, my dear student. You know that molarity is equals to, molarity is, first of all, yes, normality is equals to molarity into n factor. So instead of this all normality, you can put molarity with along with the n factor. So beta, for resultant NV equals to M1 N1 V1 minus M2 N2 V2. Done beta. You can use this molarity formula also. But remember the most important segment. Volume always becomes addition. No subtraction found in volume. No subtraction found in a volume. Done beta. It is useful for titration or neutralization reaction. Done beta. It is useful for titration or neutralization reaction. Yes, only this formula is done. Now let me do another important sum here. Another important sum. Oh, already this sum is done. Wait a second. Wrong page here. Already this sum is done. Now beta, yes, another sums are here, another MCQs are here. Now beta, let we study first again stoichiometry and stoichiometry coefficients. Already we done the stoichiometry and stoichiometry coefficient. Wait a second. For chemical reaction also we done. Now I have some of the question here. Wait. Some of the question here in the file along with the some of the law, which is law of a chemical combination, right? And then some of the questions which I am going to give you in a exam, homework, sorry, in a homework. Wait a second. Yes, few question. Wait a second. First, let we understand some of the law, the theory segment. The theory segment of this chapter. Numericals all sorted. Some of the MCQ I am going to give you in a homework, right? First of all, let we study some of the law of a chemical combination. In the early age, the combination of element to form compounds is governed by the following 5 and the 6th last one, Avogadro, Dalton's atomic theory. It is not law, it is studied separately, but I am considering the same thing here, right? So let we study these following things. Law of a conservation of mass, law of a definite proportion, law of a multiple proportion, Gay-Lussac law of a gaseous volume, and Avogadro's law. Let me discuss. First, sir, what is the law of a conservation of mass? Anthony Lavoisier performed several experiments on the combustion reaction, and at the end of the combustion reaction experiment, he concluded that all the physical and chemical changes, there is a no net change in a mass during the process. During the chemical process, every chemical process, he observed total mass of reactant is always equals to total mass of product. We already proved this law in a stoichiometric calculation also. Done beta? So mass of reactant is always same as a total mass of product. So he reached at the conclusion that law of a conservation of mass, matter can neither be created nor it can be destroyed. So it is called as a law of a conservation of mass. The law is formed on the basis of several later development in chemistry. In fact, this was the result of exact measurement of masses of reactant and product and carefully planned experiment. Clear? Most of the time there is no MCQ asked from the theory segment, but the theory is given in NCERT. So we are going to discuss it. Right beta? Next question beta. Law of a definite proportion. What is definite proportion beta? This law given by a French chemist, Joseph Proust. He stated that a given compound always contains exactly the same proportion of elements by weight. It means if you found water from lake, if you found water from lake or rainwater, both the waters have a same composition of hydrogen and oxygen. Mass percentage of hydrogen and oxygen in a rain or in a store water will always be the same. Yes, beta. So it is a law of a definite proportion which is given by a French chemist. Name was Joseph Proust. Name was Joseph Proust. Then he worked with the two sample of a cupric carbonate. Which one? Cupric carbonate. So cupric carbonate, he found that percentage of copper, carbon and oxygen is same in both of the sample. Natural sample as well as synthetic sample. Both the sample have the same values. Done. Next thing, next law, law of a definite proportion. Again, see, same composition. He conclude there, irrespective of a source. Source will be whatever, natural or synthetic. The percentage of the every element is same. Please read it carefully. It is the most important law. Done, beta. Next law is law of a multiple proportion. It is also the important law. It is proposed by the Dalton, right? And according to this law, if two elements can combine to form more than one compound, the masses of one element that combine with the fixed masses of other element is a ratio of whole number. Suppose beta, hydrogen and oxygen can combine to form water, as well as hydrogen and oxygen combine to form hydrogen peroxide. Right, beta? In the both the scenario, mass of hydrogen is a fixed 2 gram, 2 gram. Mass of oxygen 16 to the 34 by 2, 16 gram. Mass of oxygen 32 gram. So with a fixed mass of one element, the mass of other element that combine is in a whole number ratio. 16 is to 32, it becomes 1 is to 2. It is called law of a multiple proportion. Law of a multiple proportion. Let me take one another example. Carbon can connect with the oxygen to produce carbon monoxide, as well as carbon can connected with oxygen to produce carbon dioxide. To produce carbon dioxide. See, fixed mass of a carbon 12 gram, both side 12 gram, can combine with the different mass of oxygen 16 gram, 32 gram. If you compare these two mass, it is in a whole numbers ratio. 16 is to 32. So it becomes 1 is to 2. It is called law of a multiple proportion. Clear, beta? It is called law of a multiple proportion. Next law, Gliese law of a gaseous volumes. Gliese gives us a law for a constant gaseous volume. This law given by the greatest scientist Gliese. He observed that when a gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. Imagine if we taking a container of 100 ml of hydrogen, it combine with the another container, two container, which have the same volume, to produce a container which have double volume, which have almost double volume. See, here it is 100 ml of H2, 100 ml of H2 combining with wait, combining with a half volume, 50 ml of hydrogen, 50 ml of oxygen, they produce exactly 100 ml of water vapor, 100 ml of water vapor. See, so these volumes are in a simple ratio, 100 is to 50 is to 100. So it is 2 is to 1 is to 2. So it is called as a Gliusic law of a gaseous volume. Now the last scientist come, which is the important one, which is Avogadro. Avogadro is the one who differentiate atom versus molecule. Till then, people called molecule as same as atom. People says hydrogen is a single atom. It can't be the diatomic. But the Avogadro is the one who clarifies their concept. Avogadro proposed that equal volume of all gases at the same temperature and pressure should contain equal number of molecules, not the atom. Avogadro made a distinction between atoms and molecules, which is quite understandable in the present days, but not at that time when Avogadro proposed this. If we consider again the reaction of hydrogen and oxygen to produce the water, to see the two volumes of hydrogen, double volume of hydrogen, combined with the one volume of oxygen to produce double volume of water without leaving any unreacted molecules. Done? So for this, Avogadro could explain the result by considering the molecules to polyatomic. For example, hydrogen is diatomic, oxygen is diatomic, and water is to be polyatomic. If hydrogen and oxygen were considered as a diatomic, which is recognized now, not that days, the above results are easily understandable, right? However, Dalton and other believed that at that time atoms of the same kind cannot combine, and molecules of oxygen or hydrogen containing two atoms did not exist. They believe that the molecule of H2 and O2 cannot be in existence. But Avogadro made bold statement, and further Avogadro proposal was published in the French journal of Physics. In spite of being correct, it did not gain much support. Avogadro was correct at that time, but people did not give any attention towards his law or statement. But then later, after 50 years, the first international conference on chemistry was held in the Karlsruhe, Germany, to resolve various ideas. And in this meeting, 𝐄𝐍𝐆𝐋𝐈𝐒, the legendary scientist, present a sketch of a cause of a chemical philosophy which emphasized the importance of Avogadro's work. Only at that time, Avogadro is the only one scientist who differentiate between atoms and molecules. Nowadays we can do easily, but at that time, Avogadro is the only one who differentiate this. And the last theory, which is Dalton's atomic theory. Dalton was the first known one. Before that, Maharshi Kanak also give definition about 𝐶𝐶. What is 𝐶𝐶? He ate fruit, apple at that time, and he thought that if I bite continuously apple and divide it into small pieces, the last smaller pieces, which is now not divisible, it is called 𝐶𝐶, right? And later on, the Dalton comes with the greatest theory, smallest invisible particle called atomino. Later on, it is known as an atom, right beta? And back of the time, Greek philosopher also gave the theory, but Dalton was famous because he gave some of the postulate about the atom, and it is like that 4 postulate which is important. Matter consists of a individual atoms. He states that any of the matter on the earth are made with this combination of small atoms. Next, all atoms of a given element have identical properties, including identical mass. Atom of a different element differ in a mass. Clear beta? Next, he suggests that compounds are formed when atoms of a different element combine in a fixed ratio. And the last one, chemical reactions involve reorganization of atoms, and these are neither created nor destroyed in chemical reaction. So Dalton's theory could explain law of chemical combination easily. However, it could not explain the law of gaseous volume because combination of atom, which answered later by other scientists. Clear beta? Other all theories can be explained smoothly by the legendary scientist Dalton. So here it is the end part of the chapter. Now for you I am giving some of the MCQs. 1, 2, 3, 4, 5, 6, 7. Yes, 6 MCQ, right? And these all MCQs are in your DPPs. These are the PYQs which I am going to include in PPT. And yes, some of the MCQs I am giving you in the homework, which you have to do it by yourself, right? For your strong preparation of upcoming NEET examination. Answer of that homework question, answer of your homework question will be provided soon with your class note. Done beta? So I hope in this one shot UMEED lecture you clearly understand your mole concept chapter perfectly. Done? So we are going to meet soon in next upcoming chapter of physical chemistry in UMEED batch. Till there, stay tuned with PW English. Thank you so much. We are going to meet soon. Bye bye. Sayonara. Take care.